Alright, make a fair day. Just had breakfast here again. Running a little bit late, but I don't mind. The make a fair's on all day. I'm not sure I'll miss too much, but I'm heading out now, so it's all good. Alright, I'm across the street again under the fig tree, and here's the outside of the College of Arts building. It's the guy with the land yachts. Some metalwork sculptures. There's a couple of other things I can't see there from the outside, and I've got a ticket to ride. I don't know if they're actually checking them or if that was just kind of a formality to see how many people are going to be interested in the event. Anyway, I'm going to head in. Questions people have been asking you about them.
Well, besides what is it?
Yeah.
What do you do with it?
What do you do with it?
Yeah.
Well,
it's common, but this is made to suit my lifestyle.
Yeah.
Which I put my water and swag in there and food, and
yeah.
I go walk about for a couple of months.
Did I see? I don't know if I was using my own imagination, but did I see you were prospecting? That was part of your gig, or no?
No, not me. No. I was prospecting.
All right. Okay. Well, I must have been thinking at the time. I must have been thinking, oh, that'd be useful if you're a prospector and you were just, I don't know, because they got to, sort of traverse their claim from day to day. It'd be a fun way to do it.
Well, you have a bit of problems, with those things off wheels. You've got three-corner jacks and flat tyres and, and all that sort of thing, So I tend to try and keep it to, say, rural roads and stock routes, actually.
Yeah. Oh, okay.
Stock routes are really interesting.
Yeah. On the stock routes, are there still corrugations in the dirt on stock routes?
Well, they could be washed out. They can, yeah. See,
because I imagine that'd be one thing that would slow you down.
Basically, speed's not the quest.
Yep.
The quest is, I'm 67.
Yeah.
And I was 147 kilos. Right.
Yeah.
So this is basically an exercise machine.
Oh, okay.
That's where it's, and rather than sit on a treadmill in a house or something like that, this is my exercise.
All right.
And that's what I will do now. This is the only thing I've had to do for this part of the year. I will set it up and I'll go for a walkabout.
All right. So do you have to, do you find yourself having to run up and down pulling ropes and whatever? I mean, it looks like you've got it set up there so that you can do that from the chair.
Yeah, well, not only the chair, the thing is that this drops down. That's a steering wheel. That's a self-centering device.
Oh, okay, so you can do it from the back.
Yeah, and if it's a hard rise, like you don't go on hilly country, but if it's a hard rise and you push it to the top, I reckon you should be able to ride down the back. And the easiest way is to jump on. Can't do it now.
No, no, that's right. I understand where you're going with that. Yeah.
Jump on, you can steer it from there and enjoy the ride.
That's very cool. So, have you made many of these?
Oh yes, yeah.
Oh, okay. And you've got several customers that have commissioned them.
Several what?
Customers that have commissioned them, asked you to build one for them.
I don't know, but if you're really, really, really interested, there's this site. Seabreeze, and if you register and sign in there and go to the forums, land yachting, and you look down it, there's about 1,000 pages of information.
All right.
There are commercial ones available, about $4,500.
Yeah, right.
But most of us blokes, us old blokes, we build them ourselves, and a really popular one that you can just fold up and put in the boot of your car is about $400 to $500.
All right.
But against $4,500. But this one over 10 years has probably cost me $10,000. You know?
Oh, okay.
But
just in repairs and fixing stuff up,
not
or
repairs. I've changed it down.
Oh, okay, modifications.
I've got a bit older. See, it used to have. I used to have it with. You haven't got a light there.
Oh, it's alright, I think I can see it there. Yeah.
I used to have solar panels on the top. I used to have an electric fridge.
Yeah, okay, that's 50, the way to travel.
50 litres of water.
Alright, yeah, I guess you need that in some of the roads you're going, yeah.
Well, you've got to carry a lot of water because you've got to be able to wash your body. That's the biggest thing.
Okay,
you
yeah.
know? You've got to armpits and crutches.
Yeah, right. I gotcha.
Every day. You know? But yeah, I've done about, set up like that, I've probably done about 3,000 kilometres around the place.
All right, nice.
And that was near Robertstown. So I told it a bit.
Yeah, okay, cool.
Yeah.
Is there, like it sounds like from the website and talking about the forums that there's a bit of a community of other people land yachting?
Oh yeah, worldwide, it's big.
Yeah? Do you go on rallies, or you do mostly just travelling around by yourself?
My thing is travelling by myself. I go, I mean they sail out at Port Caller and stuff like that. I go out there occasionally, but the headquarters of land yachting in Australia is Lake Lefroy in Western Australia, in Cambodia.
Okay.
And they have a couple of pretty good meetings a year. And I'm going over there for the November one, you know.
Okay, alright.
But, yeah, we're mostly just individual tinkerers, and we just keep in touch on the website, and, you know, different ideas. People try different ideas, and I mess around a lot, you know, so it's fun.
Alright.
It's good exercise for the mind, good for the body.
It's a bit hard. I've known people that I did railway places that I did with up at the pole of railway. Always keep holding integrated circuits and gold and interesting terrain with the view to doing something creative right there. I went to a bridge stone with a later.
Because it's enamel, I don't know what it is, but I would think any thin metal would do the job because then I could paint it. Well, if I can't get an enamel, I'll just use a gloss enamel paint.
And this is still in the making, this one. Yep. So, power on, and that one drives a hub motor. This one drives chain ring. So you can use all the gears with this one. Can you click on that as I'm okay? Click, and again, and again.
How easy is that?
So that will get you up to about 45 km.
Yeah, that's right. Warehouse.
Not entirely legal.
What was I saying? You had what? 25 horsepower? Or a little? No,
200 watts.
200 watts. So what sort of wattage do you have
So
here?
that's legal, that one.
So legal.
This one's 600 bucks. Just an experiment.
What sort of battery?
Lithium phosphate. No, the latest technology is called lithium. That's lithium ion. That's lithium phosphate.
What range do you get?
30 k's. That one about 20. This one I don't know yet. I haven't range tested it.
Possibly considerably more? No?
That's what I think so.
Extra batteries.
Yeah. So there's 9 amp hours of batteries. Amp hours is like your fuel tank. That's about 10 amp hour. These are 40 amp hour cells. 16 individual cells.
It's just a simple off one switch.
This one, yeah. That's it. And this doesn't have a toggle. It's just pedal. And the current kicks in.
And mine's actually in the hub. Pedal power and
Brakes are running.
Leaving my car away.
Yes, basically, I've been riding this one for about 3 years. Nearly every day. Battery's still.
I was about to say battery which doesn't work very well. It's too skinny. It was working really well. You'd be building up to, you know.
Yeah. And that one, not electric yet.
Yeah, of course. Now, that's just a receded end of
My crazy idea I had in my head.
Yeah, that's right. I wanted it to be too quick like that.
But it didn't work.
Put the old bikes on penny farthing. Yeah. Did you actually start with penny farthing? Where'd you get the route from? Progressive, mate?
I made the spokes.
Yep.
The velocity in the city.
Yep.
Hubs from our guy here in Adelaide. He had all the right things. It's just stainless steel rod. Bend it over at the end. A little die that you can sort of tap at the end of it with a hammer. Dip it in some lime to toughen it. And then a little thread cutter on the other end. And you've also got a calculator. You type in that diameter, and it works out exactly as spoken. Yeah. Yeah.
Smiley pedals.
Very cool. Oh, okay. All right. So, he actually invented it.
Trev, the electric vehicle, it was designed and built by students at the University of South Australia.
Yep.
We used to build and race solar racing cars, and we figured that if we can drive it across Australia without using petrol, we should be able to get to work and back without using petrol.
Mm-hmm.
So we built this small car. The secret to it is, can you come and help me here? Just stand behind the car and give it a push. It's really easy.
Aha.
So it's very lightweight, so it doesn't take a lot of energy to drive. So we've actually driven this 28,000 kilometres around the world, and it cost us $400 worth of electricity.
Right, you were doing, so it was kind of, I was going to say marketed, that's the wrong word, but it was talked about as around the world in 80 days.
Yeah, it was 80 days of driving.
Right, okay. So it was 80 days of driving, but not necessarily around the world. Did you ship it to other?
So once we started in Geneva. Once we got to Shanghai, we had to stick it on a boat to take
Okay,
it to Toronto, not Toronto, Vancouver.
Okay.
And then again, after we'd done America, we stuck it on a boat, take it back to Africa.
All right. That's cool. So when you say $400 worth of, so you're comparing. Oh, hang on. That's how much it would have cost to recharge.
Cost of electricity to recharge.
Yeah, that's very cool. Yeah, $400. Yeah, no. When I saw the copy, it said wind power. So.
Well, yeah.
No. I get the.
We before we left, we worked out how much energy it was going to take, and we bought that much electricity from a wind farm.
Right.
They gave it to South Australians.
Right. Okay.
So the world owed us.
I gotcha. Yeah, no, it's very cool. And so there were two people riding it?
Yeah, some of the time. Some of the time it was just one person. Some of the time it was two.
How big was the team?
There were generally just two people, one or two people with the vehicle for most of the event.
And on the technical side, the motor, are they in-hub or are they?
It's a Vectrix electric scooter rear end.
Oh, okay.
So it's motor on one side of the wheel. It's got a planetary reduction gear on the other side. Not the way we would do it next time. It's too much unsprung weight, so we need to get the weight off the back wheel further up the swinger. And
were you using any of the other Vectrix gear in it, or just the?
Yeah, it was just the swinger.
And the controller?
Custom.
Custom. Okay, very cool. All right. So I guess that was one thing I was interested in, was how much of the staff and students of UniSA sort of put their own designs into it.
Yeah, so I mean, we started with industrial design students, designed the concept of the vehicle, and then our mechanical engineering students, electrical engineering students did a whole lot of stuff. So, we obviously tyres and wheels and brakes and stuff you buy off the shelf, but the suspension design is our own, the body is our own, the motor controller, all the electronics is our own.
Yeah. The brakes are mechanical, or?
Yeah.
Sorry.
We don't have regen running at the moment. We didn't need it going around the world, but it's just a software change.
But you didn't have to put a vacuum in there. That's pedal to the brake.
No, it's motorcycle brakes.
Oh, okay.
So, and because the car is 300 kilograms, you don't need a vacuum assist.
No. Okay, fair enough. Yeah, I got you.
And weighs less than a Honda Goldwing or something like that.
Okay. And the batteries, that's always a really difficult choice for electric vehicles, like the price versus performance.
So we went, because when we first built it, we had 40 kilograms of lithium-ion polymer in the front. When we had to go around the world, we wanted the best performance. Basically, we were interested in watt hours per kilogram. So we've got lithium-ion polymer, and we paid for it.
Okay, all right.
So they were very expensive, and we were ripped off. But,
no. Well, if the thing works in the end, people forget about the cost after a while.
That's right. Yeah, and it's got a range of over 200 kilometres.
All right. With those lithium polymers, did you get satchels and make your own packs, or?
Essentially, yeah. So we've got there's 35 pouch cells.
Pouch cells, that's what I mean.
11 mils thick. 35 of them, just in 5 packs underneath the car.
And you've the battery management was designed.
No, we got an off-the-shelf lithium battery management system.
All right. Okay. All right.
We had previously designed and built our own.
Yeah, but
for going around the world, we wanted something that was commercially tested.
Right. Okay. Fair enough. Yeah. All right. Very cool. And are there further plans for the car? Other challenges?
Not for this one. We've kind of taken this one as far as we can. Like our aim was to demonstrate a low energy, high efficiency, low mass vehicle. Something very simple you can drive around town. Our next project is developing solar cars to use as taxis in Africa.
Oh wow! Okay.
Transporting pregnant women from rural villages to hospitals.
Wow, that's very ambitious. Very cool.
Yeah, so we've got about a year to build 3 vehicles.
Okay. How did that come about? Who was the catalyst for?
a non-government organisation in Zimbabwe rang me up one day and said,
Oh, okay, they contacted you. Okay.
we want solar cars. And I said, no, you really don't. But then they convinced me that they did because they've got a petrol-powered ambulance, but they can't get petrol for it.
Right, okay.
They basically reserve it for emergencies. They want something they can use daily just to go and collect women from villages and bring them into hospital.
Yeah, all right. How would you go about, because, I mean, you can put solar cells on the roof and sides and whatnot, and that gives a little bit, but I assume that you'd be more inclined to fill the car with batteries and have a solar station in this town, a solar station in another town.
We're planning to have, so the villages are, from the hospital to the furthest village is about 80 kilometres. So we're planning to have 2 solar charging stations that will basically, solar panels charging up batteries, and then we'll drive the car up to one of those and either probably transfer the charge, maybe swap batteries, but
okay,
probably just transfer the charge.
And I mean, I guess there's, I'd like to think anyway, that there's some goodwill on the part of AEVA, but is there also Zimbabwe are footing some of the bill for this?
We've been to Zimbabwe.
Yeah. Okay, so you've already done
talking to stakeholders.
Yeah, right.
Our main thing was to look at the roads because
see how viable
the roads were going to be pretty dodgy.
Yeah, okay.
And they are. So we're getting support from, basically logistical support from the hospital, from the NGO, from the health department.
Okay, cool.
We're going to talk to the Adelaide branch of the AEVA in the next couple of weeks to just see who we can get interested there. But when it comes to funding it, we will go out and we'll find sponsors, just as we did to drive this around the world.
Yeah, well, it sounds like a worthwhile thing. I'm sure you won't have any trouble finding sponsors for it. Just what you were talking about with the roads, does that mean that you would have to try to incorporate some four-wheel drive capability?
We won't have to go four-wheel drive, but we will have to go 4 wheels, and it needs to be really rugged tyres, so we're looking at ATV wheels and tyres on the thing. So, all right. The roads are bitumen, but they were built 30 years ago and had no maintenance. So they're just potholes and rough edges and that sort of thing. So.
All right. And AEVA South Australia itself, how are they going? Healthy club?
I'm not sure. I'm not.
Oh, you haven't been to a meeting for a while?
I haven't. I'm not a member, but I keep bumping into events like this.
Okay, all right.
But these are the guys to talk to about.
All right. Okay, I'll have a chat to them. Technical tour of the car. Some things I do recognise. I see that you've got 6.7-inch advanced DC in there.
That's right.
So that's a fairly popular motor, traction motor.
4001.
Yeah.
55 horsepower peak.
55. So how many ponies were in the car before you did the conversion?
I think it was very similar.
Okay, yeah. And I think I've found that with this sort of size car and that type of conversion that
it wouldn't have been any more than that because you're not supposed to put any more in. but
certainly not.
But nominal 16 horsepower.
And the controller here is
Ziva, Australian made.
Yeah. So who's making them?
Ian Hooper from Ziva.
Oh, okay. Yes, Western Australia.
That's right.
Yeah.
Does a great job.
Yeah. I think I met him a little while ago at the, I don't know if I officially met him, but saw him at the Canberra show.
I met him. I think I met him there first time as well.
Oh, right, okay. Yeah. Well, did you have
2009?
Would you have had your car there, or you were just there visiting? You didn't.
I had this. The first time I had this on display was at the 2010 show in Victoria Square.
Okay, I wasn't there for that. Okay. All right, and I saw that you were doing the accessories conversion with a Meanwell converter. How's that working out? I did have. Okay.
That's failed now.
Okay. I've heard
2 years that lasted.
2 years is pretty good. I've heard a couple of problems with the DC to DC converters for accessories, and I don't know. My first sort of guess is that it's just a power rating thing. But is it? Do you think it might be that they're getting spikes from the traction?
Well, possibly. I didn't have a diode in series with that one. I've since now learned. I haven't actually got this one wired at the moment, but I've got a big diode I'm putting in series and an inductor when I finally wire it in, and that'll stop the with this motor controller trying to draw power from that.
Yeah.
As the battery droops,
Right.
this is still high.
Okay.
And I think that's what
So you
blows
think
them
it's
up.
coming back in the other direction?
Yeah.
Okay. All right. So what have you got in there at the moment then for your accessories?
The accessory battery gets charged up with an onboard 240 volt charger overnight. When I charge the main
Okay.
batteries, that also charges this.
So you haven't got the traction pack wired through at the moment to the accessories battery?
No. Eventually, those plugs there will be wired up through to the high tension.
Okay. And a picture there of the battery management module. That does look familiar.
That's also from Western Australia.
Okay. Yeah. Okay. So that's
Rod
also
Dilks,
Rod Dilks.
EV
Yep.
Power.
Yep. Okay. I know the name. Yep.
Yeah, it does a great job.
Yeah.
I haven't had any problems at all with
No, I don't think I've heard any bad things about that one.
it. It's great. As long as you wire them up properly.
Yeah. Right. Yeah. And your clutch plate.
The clutch plate, I've used the centre of the clutch plate to be part of the coupler.
Sorry, the coupling plate. I mean, I guess.
Yeah, the coupler was turned from steel, and the centre of the clutch plate bolted to the coupler.
Right. So in Sydney, there's a couple of guys kind of associated with the association that are sort of fitter turner kind of guys. So have you got a couple of regulars that are now familiar with doing these for
A friend of mine
conversions?
runs a engineering shop, and
Okay.
he does it, and he's done it quite a few for the members now.
Yeah. Okay. Yeah. That seems to be the go
He
once.
does a magic job for both the adapter. He actually turned the adapter plate
Yeah.
on a lathe, so that was
Yeah, that seems to be
pretty
the
nice to
go. Well, it seems to be the go once people have found someone who understands what they want and has done a good job for someone else. So they'll go back
There's
to
actually
them.
a YouTube video of that being turned.
Oh, okay, all right. Links from your website?
Yeah.
All right. Well, I might just there's the website there, and find that off your website. So most of the pack then, or all of the pack is in the back?
All the packs in the back.
Some people do split them front and back. Do you want to give us
so much room left for batteries.
all right. Do you want to give us a look around the back then?
Sure. It's a bit dark in there, but you can see all the lights on.
Yeah, it's a. It's
So
a
there's actually 40 lithium iron phosphate Thunder Sky batteries, and they're 90 ampere hour.
and they're another popular choice for conversions. Although I think there is another battery company that people
Sky
have been,
Energy.
That might be the one.
Yeah,
that people have
Calb
been
now.
talking
It's
about.
called Calb.
Have people noticed much of a difference between those two types of batteries?
No, not really.
No, that's
Actually, Calb are making a new cell now. They're making the Calb CA cell, which is supposed to be better than both the Sky Energy and the Thunder Sky.
oh okay, all right, and
More energy.
a bit more dollars as well.
I'm not too sure. I think they're around about the same.
Okay, because that seems to be the sort of pain point for a lot of people that I've talked to doing conversions is that choice for battery.
Yeah. No, these have been going for about 2.5 years now. And I've done about 25,000 on these.
That's pretty good. That's very good. 25,000 on the one set of batteries. Have any of them shown
No.
any sign? No. Okay.
No, they're all balanced very well.
Yeah,
When
excellent.
on the end of the charge, they all come up to the same balance point within about 2 minutes.
All right. Yeah, that's very good. Like sometimes you do get the depending on what's happened with the pack or the history of the batteries, sometimes you do get one that I've seen on others that maybe 10, 15 minutes to come up to the rest of the pack.
These are all very, very close.
Is this your daily driver?
Yes. Yes, my wife drives a Prius.
Oh, okay.
I drive this. I'm going to do the conversion of the Prius to plug in soon.
Oh, okay, cool. And add a few batteries into the Prius as
Yes,
well?
another 10 kilowatt hours.
Yep.
Adding on to the original pack.
Yeah. What sort of
pack stays there?
Okay, what sort of batteries are you putting in for that?
They're going to be 40 ampere hour.
40 ampere and
Probably Calb
okay, all right.
cells.
And
That'll give it a range of about probably 70 to 80 k's on just battery.
okay.
But the petrol motor will still be coming on if you accelerate hard or you go up hills and stuff.
Sure. And have you got a fancy? Well, I know a lot of people try to fit the recharge port into the into the petrol cap.
It's in the like caravan inlet.
Yeah, which is a sort of natural place to put it.
That's just it there. That's it. 15 amp inlet.
Nice. Have you found? I'm from Sydney, obviously. How does South Australia go for finding places to plug in other than home?
We've got a couple charge points in the central market. And
okay,
another
cool.
couple in the car park above the bus station.
All right, yeah, that's good.
And it's all free charging.
All right.
The central market's free parking as well.
Oh, okay. Oh, that's good. That's good. Is that something that you had to, that Ava had to, I don't know, talk to the council or government about, or did they sort of offer it without being asked?
There was one of our enthusiasts. He actually pushed the council into organising a couple in one of the car parks, and possibly even started the process for the charge point ones as well, the commercial ones.
Okay, that's very cool. Hopefully there'll be more. Yeah, I'm not quite sure what the situation
There's one up
is.
in Stirling as well, so people venturing up to the hills.
Ah, yeah. Yeah, that's good.
Cafe up there.
Because all you need is one somewhere else to sort of, even if it's not for extending your trip, even if it's only for sort of security of mind for that trip. So if you've kind of calculated that you'll get there and back, but there's not a lot of overhead in between. I
normally plan the trip. I've got an extension cord if I need to knock on someone's door.
Yep. Friends in every suburb.
Well, the idea was with the club was to have a register on the website where people could actually members that offer power, so that'd be handy. Get that going.
Have many of them? Well, you were saying that was the plan, but have many of them offered anyway?
We haven't actually got it on the website yet, but we should do that.
Yeah. Okay. How is the club going,
really
by the way?
Yeah. 63 members in
63
Adelaide.
members is good. How many of them, how often, well, you usually tell by how many turn up to the regular meetings.
We meet once a month, and we would have maximum at a meeting would be probably 38. Minimum would be about 20, 25.
All right. Yeah, that's a good showing.
Very good, yeah.
Are there any sort of group projects?
Not at the moment.
No. Okay. Yeah, it's difficult.
We often have people who are doing the build. They have like a barbecue, and everyone comes and helps.
Okay, that's the way. Here, strip that wire and lay it down there.
There was one group build that was a 3-day one where we drove it into the garage on the Thursday night. That's the Thursday morning. And Saturday evening we drove out as an electric car.
Okay, cool.
That was good.
Are there many in the club, is it Mick?
Yeah.
Many in the club here that are interested in bike and motorcycle conversions?
There's a few members that have actually done conversions on bikes and just purchasing bikes as well, brand new ones.
Oh, right, you mean new petrol-powered bikes and converting them, or do you mean...
like Mick sells with the new glider.
Oh, right.
But yeah, a lot of members doing bikes, and there's a couple doing electric motorbikes as well as bicycles. That's all good.
Yeah, it's I think it's a good place to start as well if you're interested in electric vehicles, but you're not ready to do, a full-size vehicle conversion, but you want to, be involved, do something.
It's certainly a good learning point, doing a motorbike. Yeah, for sure. You learn not to put the batteries on the flat like Mick has.
Sorry?
Around here. Those ones there actually lay them down flat.
Oh, okay.
You don't do that. He's learned the lesson now. He has to actually charge the motorbike on its side.
Oh, okay. So the electrolyte inside
doesn't like it.
Doesn't like it.
One of our members did a Lotus Elise. I was helping him do the Lotus Elise.
Oh wow! Yeah.
And he had a whole 25 cells laying flat, and 12 of them all at once died.
Really? Oh, okay.
And they went right down to like half a volt. And we managed to revive them.
Okay.
And
yeah, that's something that I
then you
wasn't...
reposition them on the sides. On the side it's okay, but not on the flat.
Yeah, okay, that's something that I wasn't sure about, with, especially with the Thunder Skies are what I'm sort of more familiar with.
Yeah.
I wasn't quite sure exactly what happened. They're a very, very tightly sealed battery, and it's... I was trying to imagine how much inside was floating about, but obviously...
There's only, I think 4 tablespoons or something, like someone told me at one stage.
Okay, all right. So you want that 4 tablespoons in the right place.
Yeah. So if they're lying flat, the top cells don't get
anything.
They dry out.
Right.
And if you lie them on the side, it's fine because they're all the plates are in contact with the electrolyte, and of course, obviously, vertical, it's fine as well. Obviously.
Yeah. Okay.
But yeah, it's amazing. Some people say, even the manufacturer reckons it doesn't matter which way you put them, but it definitely does.
Yep.
They die if you have them flat.
Okay, all right, good to know, good to know. Do you have a, what we call a Jesus button, emergency button
I do.
in the car, break off?
There's one between the seats. It's a bit hard to see from outside, but there's a circuit breaker between the seats. Oh, you can see it from here.
Okay.
Put your camera right across in the middle. And that actually is a combined circuit breaker and on-off switch, so you can just flip that up in emergencies.
Okay. Oh,
down.
right. Sorry, I was looking in the wrong
Flip
spot.
it down in emergencies, yeah.
Right, I gotcha. Yeah, some people have got...
So that removes the power from the whole of the front.
Yeah.
Very close to the battery.
Yeah. That's...
Some people have little push switches.
Yeah, the mushroom button, yeah.
This
And
one doesn't need it.
there was another one that I saw. I'm not quite sure what the... I think it might have been it wasn't a lever. It was... I can't remember what it was, but...
Some people hook those up and under here with a pull cord.
Oh, that must have been what it was. Yeah,
like a choke cord on it.
Yeah.
But it's also got a safety switch here, which is a crash inertia switch. So in case of a crash, it'll pop up and remove power from the
I think
from the car.
I've seen that a few times in these
Actually
conversions.
disables the contactor. The contactor's hidden behind here. That's the contactor there.
And contactors are pretty big in these conversions. They're
Yeah.
fun little bit of hardware.
They're generally 250 amps.
250 amps, yeah.
Or something.
Makes a good clunk when you turn the switch. And we were
That's how you know it's on, actually.
That's how you know it's on.
It clunks as the contactor comes in.
Because otherwise you don't know if there's... You've put a few lights and stuff on the dash. Have you done any conversion with the instrument cluster? Or do you have any readouts there on the dash?
Tacho, I had to convert the signal. The original engine had a tacho connected to the coil.
Yep.
So there was high voltage pulses coming off the coil. So I had to make up a box, that box there, to convert the sensor, which is the Hall effect sensor output, to high voltage pulses to feed the original tacho.
Yeah. So have you taken that off the adapter plate? Well, actually,
no, it's on the end of the motor. There's a little circular. It's very hard to see right down there.
Okay, I'll take your word for it. But you've got a notch in the.
It's got a little cylinder actually with 2 notches in it, 2 holes in it.
Yep. Okay.
It goes through a little sensor.
You get 2 blips per revolution.
2 blips.
Yeah. Okay. And is that what the engine originally did? Right. Okay. Because I have helped out on other conversions where the tacho wanted like I don't know 3 blips per revolution, but there was only 1 notch in the sensor was on the adapter plate, and on the coupler. Sorry, I know I keep calling them the wrong things, and so I had to make a little thing that would convert 1 revolution into 3 blips, that sort of thing. So that's interesting. So just the tacho?
Just the tacho, yeah.
And have you got any indication for...
I've got the Expert Pro gauge for the high voltage system.
Oh, okay.
It shows you volts, current, ampere hours used, percentage.
Oh, okay. So
that sort of stuff.
The displays on the dash?
Yep.
Do you mind if I... Oh, okay. It's quite a big display there.
The bottom one's the 12 volt one, the round one at the top is the high voltage one. Just put it down in the console.
Come on, focus. Alright. It's a bit dark in there. Very cool. Alright. Yeah, too dark. That's alright. Alright.
We've got Josh Lady and then Software Engineering Google talking about buying his house and 4 sets of boils and commercial house. But also there's lots of you can do all the way up to the third floor and then outside the basement. Make sure you check out all of the floors and head outside and around the building.
G'day, how's it going?
Yeah, not too bad.
Very cool. Do you mind if I have you on camera? No. Sorry, what's your name?
Mark.
Hey, how's it going, Mark? JD. It's a cool idea. Where'd you come up with the idea? It sounded like you had an interest in the overland telegraph, yeah.
Yeah, well, I've seen it. I've always seen it just rusting alongside the train tracks on the way up, you know, on the old route. So, and then, yeah, just sort of found it amazing to think that, you know, now we're milliseconds away when we do a tweet, but realistically, even back then, it used to take an hour or two to get to somewhere like New York. And before that, it would be on a ship, so it'd be months behind the news. So, yeah, originally I wanted to recreate the entire telegraph system.
Oh, okay.
I wanted to have like mobile phones connected to each one of these.
Right, relay it.
So retweet all the way up, all the way from here to Darwin and back.
Okay, yeah, that'd be an interesting project, yeah.
Yeah, but in the end it was too hard to find enough Morse keys to actually do the job.
Oh, okay, have you been collecting Morse keys?
Yeah.
Only straight keys?
Yes.
No iambic?
I don't know how I'd implement them into my system. I bought this one without actually thinking about it, and I ended up having to drill a hole in it, which was sacrilege.
Yeah.
But yeah, so this is what I ended up with. So, yeah.
How's your Morse? Not at all, or you've learned a couple of
yeah, I've learned
letters?
a couple of things, but nothing. Yeah, but yeah, the interest was the whole system is only running at about a third to a half of what an actual telegraph operator could run at.
Yeah, yeah.
So they could do 60 words a minute. This is around about 20.
Okay.
Because I couldn't get the electronics to keep up. These wouldn't discharge in time, and they just stuck down. So.
Yeah, yeah. I guess you need. I don't know. I'm not quite sure what you do, like a push-pull motor kind of thing.
Yeah. Originally, they would have had magnets, and they would have cooled it down.
Oh, right.
And they would have discharged a little bit quicker. But yeah, it's
alright.
Yeah.
And the actual hardware side of things here is running on.
So we got Android here. It's actually sending what we call a DTMF tone. So
yep. Okay.
when you call someone, you press 1, 2, 3, 4. That's a DTMF tone.
Yep.
There's a DTMF decoder, and then that goes out to a decimal binary to decimal converter, and then it's into the transistors that run it.
All right.
Thanks, guys.
When are you doing it? When are you going?
I'm going to
Laser printing with the Fab Lab.
and training. Wedding
And 3D printing with Innovation Lab. You can see how popular it is here. I'm going to go into the theatre and have a look and see what Josh Bailey's got to say for himself from Google.
Connected directly to the top wire there, which is at about 1 million volts. So I'm reconciling my situation to myself by saying, well, there's actually no voltage difference between me and that top wire. So I'm really at 0 volts, and the rest of you are at some weird negative voltage, like -1 million. So that must be very strange for you. But one of the neat things you can do while you're up there, as opposed to being on the ground, is you can take like a broom handle and poke it out through the field. The arc will start off the end of the broom handle and hit the ground, so you can kind of steer it around a bit. You can do that to try and like get people on the ground to make them run away. Really want to do that because that would be very irresponsible. But actually, you can just hear my friend Greg at the controls in the background. So one of his favorite things to do is call up to me, say, hey Josh, you do believe in Faraday's law, right? And I'll say, yep. He's like, okay, otherwise you're going to die. So let me show you another short video that shows you something from the other end of the spectrum. Okay, looks like the computer's crawling kind of here a bit. But what's happening there, that's one of my small coils in the foreground. And a couple of my friends there and I came up with a computer interface that allows us to put up to 4 voices, kind of arpeggio effects, velocity control, all that kind of stuff, and have it play as part of a whole set of electronic instruments. So that's actually the smaller one. We actually got like a larger one that's a bit larger than me that can do up to about a 2-meter arc and perform the same kind of effects. So anyway, why do this? Why live in a converted warehouse space with 3-phase power? I'll just give you a presentation as to why, and you can judge for yourself whether it's a good idea. Okay, apparently it's 2013, so my remote doesn't work here, so I have to use this 8-bit aesthetic scrolling display here, which will add to the tone. Okay. So all the coils have names. Actually, most of my projects have names, and most of them are obscure literary references. So if anyone can guess what perimeter is by the end of the presentation, I'd be interested to know. No one's done it so far. So this is a coil I built with a friend of mine, Patrick. Definitely a team effort. He did all the hard work of actually building the thing. And what I hope to do here is give you brief introduction to Tesla coils, some of little discussion of some high voltage effects you can achieve with them, what you can do if you connect your computer to a Tesla coil, not have the computer blow up obviously, and some of the research applications, which are all completely serious, I assure you. So I have to make the obligatory statement here. Coils are actually pretty easy to build, and it's also quite easy to die as a result. So it'd be a really good idea if you want to go build one to ask somebody who knows more than you to steer in the right direction. However, I will say I am a software engineer and I went to university for about 3 months. I've got no business going anywhere near this, and I'm mostly still alive. So if I can do it, I'm sure everybody here can. Okay, so what's a Tesla coil? I guess just search on YouTube, right? Or Oatmeal or that guy. As a drone friend of mine insisted, it's not actually a Tulsa coil. A Tulsa coil, as everybody knows, was invented in Oklahoma to scare the crows. Actually, that's a lie. It's not that. It's also not a Van de Graaff generator. A Van de Graaff generator is a totally different device that's generally mechanical, and it generates a static charge, which you can do things like put your hand on and have your hair stay on end if you've got any hair. That can be kind of fun. I had somebody actually confuse this with a Tesla coil on a thread that had Tim O'Reilly on it. Tim O'Reilly saw I had a nice little warning sign on my coil saying, do not touch this. Not only will it kill you, it will hurt the entire time you're dying. And someone else posted on the thread, it's Tesla coils, they've got a small amount of amps or volts or some other nonsense. It's perfectly safe to test or touch. So I'm like, you know what, you're welcome to put your face in there and see what happens. We'll see how safe it is. Anyway, what a Tesla coil actually is a resonant transformer. So it uses a different principle, but it does the same job as a transformer you might see by the side of the street or on the road that converts one voltage to another voltage. So Tesla coils are really extremely complex and highly technical. They involve resonance. I don't know if anyone's heard of resonance, except everybody has. It's a familiar principle of someone sitting on a swing. If you want to make the person go higher, or fall off and have a horrible accident, you can actually just pick the right time to push them to push more energy into the system. And that's pretty much it. So I'm actually going to show you, if you remember nothing else about this presentation, Tesla coiling in one slide. So here's a picture of my oscilloscope connected to one of my coils there. And on the top side, this is me pushing power into the system, kind of womp womp, 2 times. On the bottom side, there's energy building in the secondary and staying up there. So that's pretty much it. It's just resonance. All the magic is in picking exactly the right time to turn the power on and building a system that's capable of receiving that power and storing it. That's pretty much it. Now, for some reason, I get a lot of questions about why, what good are Tesla coils, why do you have them? And I'm really confused as to why this is even a question at all. But there are actually some serious uses, and a familiar serious use is actually inside some welding machines. Some welding machines based on DC can only initially generate a very small arc, and you need kind of a boost to get it going. So there's a little Tesla coil in there that just gives it a boost to get it going. So you actually, Tesla coils are actually all over the place, not just video games and bad movies. And let's not forget wireless power. So one of the great things about wireless power is that it's wireless. One of the great things, the downsides of wireless power is you get the power whether you want it or not. There are a couple of different techniques you can use. Some of them are very near field, so you actually have to put the devices right next to each other. But some friends of mine published a paper where we've actually built an actual Tesla Roadster. So it's actually a little vehicle that can receive several hundred watts. You can actually drive around on it. You don't actually want to step off it because you might die. You do have to use the appropriate driving kind of special high voltage gloves. And for the ground connection, this is my favorite piece of the design aesthetic. There's a piece of chain that trails along sparks kind of behind you. It's kind of exciting. And we also put a safety gap in there to dump the excess energy, so as you get too close to the transmitting coil, it starts arcing under where you're sitting, just to remind you that, by the way, you're in a high-power electric field. Just wanted to give you a heads up. Anyway, some problems remain in making it practical. I'm sure the problems will be solved any day now. So this is actually Tesla's kind of iconic picture here of his last unfinished wireless power experiment. All kinds of conspiracy theories about what this thing was, what it was capable of doing. A lot of debate about that. My own position on the kind of debate is, with a lot of work, you probably could have transmitted maybe a few thousand watts, maybe a few miles, plus made a few things glow, and used a lot of power. But I mean, that's still cool. I mean, I like that. I don't think you could use it for mind control, though. Okay, so here's how to make a Tesla coil in about 10 minutes or less. You want to start with a traditional, maybe Tesla-style Tesla coil. Here he is doing in one of his typical pictures with a double exposure there in the background, just kind of hanging out, reading his iPhone or something, while the system is running in the foreground.
He's able to come and be part of the Adelaide Mini Maker Faire now. Dominic's a scribbler instructor and a computer engineer, and has brought along his Open Rove robot, and I'm sure you'll be delighted to learn a little bit more about what that all is. So please welcome Dominic.
Nice to be here. So play it on. What, that one? That's just acrylic. It's 3mm acrylic.
Oh, so you can just buy it in a tube?
Yeah. You just get them. I had some.
Okay, thank you, and good. It's great to see a big crowd. Look, these guys need no introduction, really. I mean, I grew up watching the Curiosity Show, as indeed many young Australian children did. These guys are absolute legends in their own lifetime. Some of the best science communicators you could ever come across, and it's an absolute delight that we've got them for a whole hour. So I'm sure you'll be absolutely amazed by what they're going to show you today. So please welcome Dean and Rob.
Thank you very much. Will you just bear with me while I adjust this slightly, because you would not have noticed we're just marginally different heights. There we go. I'm Rob, he's Dean. Look, we were delighted to be asked to come along and talk this, and slightly wondering why, because the Curiosity Show that we both did together finished in 1990, and it's a while ago, but I think it's because it was a program for young people which particularly emphasised the need for making and doing that probably got us a gig here. So again, I'd add my thanks to the organisers, and I'm sure Dean does too. It's been terrific, wonderful to see such a lot of activity. But for those of you who never saw the Curiosity Show, and there'd be a few of you here, just to give you a little bit of background, it came out of the days when channels were suddenly compelled by law to make programs for children of a school-going age. Up until then, it had really only been sort of preschooler stuff. And so we were the sort of beneficiaries of that. And if you can cast your mind back, if you can remember those days, about all there was Julius Sumner Miller, who was terrific, but back in the days of black and white television, they filmed him in a classroom. He had chalk and a blackboard. It looked like school, and he spoke to you as if you were a kind of one of an audience. And Dean and I thought we wanted to do something different. We wanted to try and capture what both of us were lucky enough to have had, and that was the parent or the uncle or the friend or the relative who would spend an hour with you making something. So we wanted to establish a sort of intimacy. We had it shot head and shoulders. We talked to people as if they were one person, however many were watching at the time, and tried to change it in various ways that Dean will talk a bit about because he's got some illustrations of it. The show went from 1972 to 1990, which 18 years, it's a good long run, and it was always national, but to begin with it was an hour-long program, it's a magazine program of all things to all people, and we didn't like that much. We changed it to a half-hour program, Science and Technology, that we wrote and presented, and that, I'm glad to say, is the show that most people remember. It also took off a bit, and it was lucky enough to get some awards. It was picked up by Germany. In the end, it went to 14 countries, and the Germans took it over. We ad-libbed it, so it never any script, so we would have to write down everything we said. The Germans would then painfully transcribe that into German, get actors with our voices, who would then lip-sync to us, and out we would come with fluent German. We still get Germans in the street who say, "Oh," and talk to us in fluent German, and are amazed and sometimes a little suspicious that we say we can't understand any of it. Anyway, they were sort of the genesis of it, and it went, as I say, till 1990. But how we did those, and some of the things we tried to inject into the program were, I think, novel at the time. They're not novel now, but I'll let Dean tell you a bit about them.
And for the benefit of those who remember, I thought we'd start by running the Curiosity Show theme song and the vision that went with it. If you feel the urge to sing along, feel free. Okay, so let's have a look at the theme song of the Curiosity Show. This may bring back memories. Do you remember?
Yes.
Good. There were three characteristics of the Curiosity Show that ran through those 18 years when we were producing the show. And they were these. You might remember that we tried to use, wherever possible, everyday materials. Jam jars instead of beakers, tin cans, pencils, rubber bands, paper clips, all those sort of things. And also we try to use close-ups as much as possible. In fact, we had a 3-camera studio to produce our show, and the normal thing in those days was to have one camera set on a wide shot or long shot showing the whole studio, one on a medium shot showing a table and somebody behind it, and one for close-ups. Rob and I said to the producers and the directors, we would rather vary that and have one camera on medium shots, table, head and shoulders of the person behind it, one on close-ups and one camera on extreme close-ups that showed people back home things that they would see better than sitting in the front row at school. So we were doing 2 things, everyday materials and using close-ups extensively. There was a third characteristic of the Curiosity show that we felt was important. That was to control the viewpoint. So these are the 3 things that we try to emphasise in every show that we did. Everyday materials, close-ups and viewpoint. Now, to remind you of some of the things we did, we'll run a little bit where we're looking at everyday materials and close-ups. You notice that in one of these segments, Rob is pointing at something underwater. He didn't use a scientific pointer of any sort, he used an ordinary common pencil because that enabled young people at home to gauge what size the little insect was. So here are a few segments of close-ups using everyday materials.
22 we're up to. 23, 24, 24. Isn't that amazing? So I'll balance it on your wrist. Normally we feel the pulse, but maybe we'll be able to see it. And there it is, rocking. You see it?
Shoots off very quickly. It can fill its body with water and squirt it out the back end.
Switch it on again, pick it up, move it across, drop it.
You see, just on the end there's a little hard lump that they can knock against the branch or each other with. There we go. Like that.
And so here's the last part. Up off the table, there we are. 13 matchsticks, all held up by just one. Try it on your friends.
I've got 2 matches with square rigged sails on them. Put one in there and one in there, much like the boat that you saw. And that is now set to sail the world. If we put it into the ocean here and we blow a wind on it, I'm going to use a straw so you can see the direction that the wind is coming from. In this case, it's behind the boat, which scoots off very effectively indeed.
So that's everyday materials and close-ups. Now, viewpoint, controlling viewpoint is a little more subtle. A couple of segments here to illustrate that. In one of them, I'm showing how you can make a fire alarm, and you'll notice the medium shot, then the close-up, then the extreme close-up. And this view that young people at home could see sitting in their beanbag munching twisties in the middle of the lounge room was better than the view they'd get in the classroom, even if they were almost nose in front of the demonstration. In demonstrations in school, typically most of the young people sitting there in the classroom don't see it from the ideal point of view. Here we enable them to see it from the absolute ideal point of view. Second segment is Rob with an illusion. The illusion is only possible if you control the viewpoint of the viewer and let them see it from a particular angle. And then the third example that we show you is one where I'm showing something and we've deliberately given the young people at home watching the wrong viewpoint. They cannot see, it's masked. But then we invite them to come around behind the table with us to see it from the ideal viewpoint. We check to see that they're watching and make sure that they know which side of the table they're on. So here's controlling viewpoint.
What happens if I place a candle underneath this little strip that's sitting here all by itself? See if you can predict what will happen and then see
close up.
Here comes the flame underneath. Watch
extreme close up.
You can see what it's doing. The end of it is bending up. It's bending up because the aluminium, which is on the bottom, expands more than copper.
What happens if you provide the brain with both those clues together?
Now an illusion.
Have another look at the cards. What's going on there? It looks like a small 5 stuck on a large 9. This is how the trick's done. Well, as you can see, it's cunningly arranged. This is what we've done, and you can do it at home if you have an old pack of cards.
How does it work?
Now here are Alexander's magic
just have
door.
A model of that temple right here. We put it underneath the altar, and slowly but surely, intriguing things happen, and the door opens. How did that work? Well, I tell you what, why don't you come around behind me and and maybe you can figure it out for yourself. Because behind the cardboard box, oh, there you are.
Just a cue to make sure that they knew what we'd done with them. Now, Rob mentioned that the show went to Germany. We thought you might be interested in seeing a little bit of the German. So here's Dean and Rob, German versions of us. Rob mentioned that people sometimes stopped us in the street and talked to us in German. I was once stopped by a guy in Rundle Mall, obviously a tourist with his family there, and he spoke to me in German, and I said nothing, and he said, "There is a man on television in Germany who could be your brother." And I said, "It is me." And he said, "No, no, no, he speaks in German, but it could be your brother." I said, "It's me, trust me." Anyway, here's Dean and Rob in German. Same theme tune.
Hallo und willkommen zur Curiosity Show. Wir haben schon oft von Seemannsknoten gesprochen, aber wisst ihr auch, was das ist? Bestimmt wisst ihr das. Aber falls manche von euch nicht wissen, wie man einen knüpft, dann zeige ich es euch.
Ui-Aufsatz benutzen. Nehmen wir mal an, ich wollte meine Wange massieren. Ich müsste nur das Gerät nehmen, mir so an die Wange setzen und anfangen, die Kurbel zu drehen. Und abgesehen davon, dass das Sprechen irgendwie schwerfällt und dass man alles doppelt sieht, wäre es eine Massage oder sowas.
So that's the German Rob and Dean. Rob, back to you.
Danke schön, mein Herr. The extraordinary thing is they do it so well at Ravensburger, they actually picked actors who have your voice. It's really quite uncanny watching it come out. Well, those are some segments from the show. We had to prepare stuff every week, and typically we would do a 4-minute, a 2-minute, and a 1-minute each. And you'd just sit there on the weekend thinking, crikey, what will I do next week? And the sort of filters would come in like, it's got to work. And we always showed whatever we made, working of it, we always showed it working. When I grew up, you had books that tell you how to make gliders, and they'd sink like a stone, and you'd think it was you, but we now know it was bad instructions. But for kids, that's disempowering. They just think, oh, I can't do that, other people can. So you'd show what you'd made so they could see if it worked, that's about how well you could get it to work, and then they'd know if they matched that, they were doing all right. But you'd have a lot of filters, you'd make something work, and you'd say, well, how can I substitute balsa for a foam, a meat tray, something like that, that kids in Orroroo can get on a Sunday. They haven't got hobby shops. And you sort of put all these filters in. But one of them was simply trying to say, what's the science behind something we can show with simple instruments? Well, I'm a musician, I play brass, and I'm going to take you through a series of things that I had on the show, all of which were to do with the science of instruments. Well, first of all, I think I have to use this, so I'm ducking in and out of it. I think a lot of kids have done this. You get a straw, you flatten the end, you cut it to a point, get 2 reeds, it's a little straw oboe. And if you cut it, you can see that as you change the length of the vibrating ear column, you'll change the pitch. Shorter is higher. Which is a great instrument if you want to play tunes that just go up. The science of it is, what do real instruments do to use that principle? Well, one of them is that you can make, and plumbers are a wonderful source of material for musical instruments. All these are plumbers, musical instruments. PVC tubing, you slice it across to make a reed, you put a bit of doweling there, shape it so that the air goes up onto the reed, and you make these different pipes of different pitches. Okay, 3 different pitches. What would they sound like together? That's where the train whistle comes from, those 3 pitches. But you can make playable instruments, and this is my favourite because you need to empty 8 bottles of wine to do it. When they had corks, who has corks now? Put them in there, tune them up, blow across the top, and you actually have a serviceable panpipe, one of the oldest instruments known. And it's, 2 octaves, you're handling a very unwieldy thing. So how do you get it into one pipe? Well, if you take a straw and do what I did without cutting it off, but you make a hole, you've got a straw which is long, a low note, and you lift it off, it's suddenly short, it's high. But you can make it low again by covering it up. the principle of the flute of the recorder. Now that's a plumber's recorder, PVC pipe, same sort of mouthpiece. If anyone's interested in this, I do have a couple of patterns to show you where to put the holes and what sort of size. You can see us at the desk afterwards. You might think I've used wonderful, cunning geometry to work out what size holes they are. I bought a cheap penny whistle and just copied them. But that makes a perfectly serviceable B-flat recorder. Easier to make, to me, not as easy to play, is the flute, where you simply block off the end with a cork and you have a hole there and you blow across it, like blowing across a bottle. I'm no good at this, as you can hear, but people who can play a flute do, and it works all right. Well, I'm a brass player, and brass players don't have reeds. They use their lips as reeds, and they make a raspberry into a tube. Comes out with a whole lot of dust as well. So that's a little brass instrument made of PVC. The brass instruments didn't use holes. At least they did once. And this was a model of an old English cornet, which is made of strips of wood bound into a tube, put holes in it, and you blew with a brass mouthpiece. Not used now, but an interesting old medieval instrument. Which blows the sound system out of the theatre. Not used, but brass instruments today use valves to add on and off bits of pipe, or they use slides. And indeed, if you get a thin straw and put a thicker one over it, and slide them in and out, you can vary the pitch with the length. Which is, of course, how the trombone works with a brass mouthpiece. Well, a PVC trom is pretty primitive, but you can make one. It's a bit sticky, but it does work, and it makes the principle of musical instruments apparent to those who make them. The woodwind used that too. Here you get a Dowling plunger and a bit of electrical conduit to make what I think is the most hideous musical instrument ever made, the Swanee whistle. Well, length and it changes pitch, but there's one other way too, and that was by harmonics. You know, if you blow across something like a cartridge case, you get one note, blow really hard, lots of energy, doubles the frequency of the vibrating air, the note jumps up to a higher pitch. Here's my plumber's version, about a metre of old hose, particularly that old hard stuff you don't like, put a funnel there, a tap attachment there, and using harmonics alone you get a very serviceable bugle. And if you've got a neighbour with a dog barking, you make one of these for every member of the family, do your practice, Sunday, 6 o'clock, you make the point. The oldest musical instrument still in existence, of course, is the Aboriginal didge, which is a brass instrument. You play with raspberries. It's used, it's made from a sort of sapling that the termites have hollowed out, and it makes wonderful sounds. And that too can be made out of PVC and dismantled for easy travelling. Well, that's a range of the musical instruments. They were all on the show, but we did other things too, and we explored a lot of technology. Old technology that children didn't know anything about, current technology that they needed to know about, and future technology that they were really interested in. And here's one of mine. It was the, pretty bedraggled now, but that was allegedly the first self-propelled flying object ever to take to the air. It was called the orthocopter, and it was made by George Cayley in the 1700s. Very bedraggled now because it's been up in the shed and the insects have been eating the feathers, but perhaps I can explain a bit more about it as we put the video on. Dean's going to do it, so I need my hands. Thanks, Dean. First of all, we'll have a quick look at George Cayley, wonderful man, pioneer of flight. And you can see some of his designs around there. He actually flew a glider with his coachman across a valley. The coachman landed, resigned on the spot. And there's the orthocopter. That's his design, and that's the one I copied here. And it's really quite interesting if you look at it. He realised that action and reaction being equal and opposite, you had to have these things rotating in opposite directions when it spun. So you needed left-handed feathers on one side and right-handed feathers on the other. And that sounds a bit silly, but chooks really do. One set curves like that, the other curves like that. So you use one lot at the top, one at the bottom. There we are. Winding it up, you can see the bow is tightening. You let it go, and it curls that, uncurls that, and off it goes. And that's about all you get out of it. Pretty quick. I'll show you in slow motion. See if you can see the counter-rotating rotors with blades there. And there it is, George Kelly's orthocopter, apparently the first self-propelled machine ever to fly. But what about mousetraps? Everyone says, build a better mousetrap, the world will be the path to your door. They don't say, what's a better use for the mousetrap you've got? And I reckon there were a few, and so I came up with them, and here they are. One of them is the mousetrap racer. Now this is already cocked and loaded, so I'm going to set it off, and you can see what happens. Not much because it broke the string, but we've got one on tape which will work a bit better. But the idea is that in a mousetrap you've got a really nice little packaged bit of potted energy which you can control in certain ways. So let's have a look at the mousetrap razor as it was back in Curiosity Show days. There it is. Rubber bands on the wheels. If you want to make one, screw eyes at the back of the mousetrap and underneath the front. I make my wheels out of ply cut with a hole saw, but you can use bought wheels. Dowling makes a nice axle, and it just fits through the screw eyes, and make sure you don't jam them up against the body of the mousetrap. The thread goes from the bar to the axle when the mousetrap is not cocked. You then cock it, wind it backwards, the rubber bands give traction, they're tyres, and you set it off, and that's what it does in your hand. Or, if it works properly, it does. That's what it does on the table. In slow-mo, you'll see the bar coming over. There it is. And that's about all you get out of it, but it's good fun. And for children, you can experiment with different sized wheels, different sized axles, and start to learn the principles of gearing. Well, people used to complain that wooden cotton reels were going out of fashion. What were they going to do? How could they do tomboy? How could they string them on string and make whatever they used to make? But I thought, what a pity. They're not seeing the beauty of the plastic cotton reels that are replacing. So I thought we'd adapt the cotton reel racer, the mousetrap racer. And so I built the mousetrap paddle wheeler. This one I think will work. Okay, slightly. It's very old, I must say. These have been in the shed too. But on film, the originals look better. So let's have a look at how you'd make one of these. There it is, in all its glory. The prototype. Screw eyes now at the back of it, and we hammer or nail the mousetrap in front of them with the bait trap near the bow of the boat. Very simple to do. There's the cotton reel I'm talking about, a beautiful precision-made turbine if you want to use it like that, but splitting between those blades gives you a series of cuts, and you can insert into them little vanes which are cut out of an ice cream container lid, because that makes them waterproof. And they slide in there and they're held by the tension of the plastic. For the axle, well, it's easy. You just put bits of plasticine inside the cotton reel, jam it down to make a good wodge with a bit of leftover dowling, and then a chassis stick is a nice thin axle, pokes through the screw eyes, another paddle on the other side, trusty old string, this time going from the bar to the axle. You can tie it on there because there's no braking when you get to the end of it. Back wind the loaded beast, off it goes, and on the surface of water it's quite a leisurely affair. And there's probably enough prod in it if you use a thin axle just to get you across a swimming pool. But again, a great thing to experiment with. And then finally, the mousetrap garden guard. Now, I got a couple of dogs, they're lovely dogs, but when I was there to control them, they wouldn't go in the garden. When I wasn't, they did, and they ruined it. And I thought, I've got to make something that keeps them away from my plants. So I thought, mousetraps are good, let's see if it works. And it does, if I can make this one go off. Do try this at home. Here's the principle. There we are. That's what it looks like in the flesh, close up. And the way we make it is like this. We've frozen. Okay, small hiatus, there we are. Hole in the mousetrap behind the bait trap, and another hole in the stake, and you align the two and then nail the mousetrap onto the stake. Again, here we use string, but just to make a little loop, which you poke through the hole, put around the bait trap, and then pull tight. Now, that will work. Dogs don't like the snapping of it, but it's much better if you make it go bang. So you put a nail in there and pull one of these things apart, a party popper. When you pull the string, that discharges the explosive, but you don't want to do that here. You want to get a bit of foil and cut the string off the explosive, and then you wrap the explosive in the foil. Why do you use foil? Because A, if it's tightly wound, it makes it weatherproof, so it'll be out there for days. Secondly, it gives you a little tail you can wind around that nail just where the bar falls. You get the principle? That's pretty well ready to go. Now you just hammer it where you want the dogs to stay away, and then fasten to the loop a whole lot of black cotton. Set them and call the dogs out. And they never went there again, did they?
As you can see, we love making things, and we made them for different purposes. Sometimes we made things on the Curiosity Show in order to solve problems. In fact, we were challenging the viewers all the time to try and work out what's going on here. One of the things, one of the problems I presented to young people watching the show was something I called the Curiosity Wheel. So have a look at this and see if you can jump ahead of us and work out what's going on inside. The Curiosity Wheel.
You are about to see the launching of the Curiosity Wheel. What is it and what does it do?
I apologise for the clothing.
Watch this. Looks like an ordinary tin can with a piece of cardboard on each end, but it behaves in a very peculiar way. We send it off across the floor, and at the appropriate moment, I will flick my fingers, and it comes back. Not only does it come back, but it keeps going. All the way back there, until I flick my fingers again, and it comes home. What on earth is happening here? Must have something curious inside it, and it does. Because wherever I send it, it seems to come back home. I tell you what, I'll explain to you what things it has inside it and then see if you can figure out what's going on. It has inside it a large rubber band and a blob of plasticine or modelling clay and 2 ice cream sticks.
Now this was a
the way in which those bits and pieces are organised or put together is of course absolutely vital. What do you know about rubber bands? You know that when you stretch them, they unstretch. When you twist them, they untwist. Which of those two do you think is the important thing for this little motor? Well, it's the twisting one. The piece of plasticine acts as a sort of a weight around the rubber band so that it holds it in place. And when the rubber band tends to twist, it stays there for a while. Any clearer? Tell you what, we need to go back to scratch and build a Curiosity Wheel. Start with a large tin can with a tin lid and carefully make a hole in the centre of the lid and also in the centre of the base. Take the lid off and then bring in your large rubber band. This is really the motor of the whole device. Make a groove in the plasticine with your finger. There we are, like that. And that's going to wrap around the rubber band. Another slightly awkward part, but you can do it if you're careful. Try and place it in about the centre of the tin, wrap your fingers around the plasticine, and then it hangs as a weight from the rubber band. So the centre of the rubber band will stay put when the edges twist. So you can now close the whole thing up, you're ready to try it.
So that was using making things in order to solve problems. But we also sometimes made things in order to challenge the senses. Let me show you something I have over here. It's a window, and it's a rather unusual looking window because it's higher on one side than the other. Instead of being a rectangle, as most windows are, this one's a trapezium. You notice that my trapezium window is sticking out of Harry Potter's head. Now, Harry is one of those lollipop holders with an electric motor inside, so when I press the button, the window should rotate. But as it rotates, I want you all to cover one eye with one hand. Just stare at it with the other eye. And before long, something strange should happen in your minds. How many can see the window going backwards and forwards? Okay, keep watching. Take your hand down from your eye. You can probably see now it's definitely going in a circle, but for some strange reason, hand back over your eye. When we look at it with one eye, we see it going backwards and forwards, oscillating. That's an optical illusion. It was invented by an American psychologist by the name of Adelaide Ames. It's called the Ames window. And you'll see these in science museums all around the world. Well, we showed that on the Curiosity Show. We had so much interest in it that we decided to make a simpler one that they could make at home with just ordinary cardboard and without an electric motor, just a piece of cotton thread to spin it with. And here's what we came up with. The Ames window in the simplest version possible.
The strangest window in the entire world. It's called the Ames window, and we showed it to you 3 years ago on an electric motor, spinning around, and it did strange things to your brain because it's an optical illusion. Well, we had so many letters about it that we decided to make another one, this time a smaller one that you can make at home. You won't need an electric motor to spin it, you can spin it with a piece of cotton thread. You'll then cut it out with a good pair of scissors or one of these safe
shorten the segment,
and you'll end up with a piece of cardboard shaped like that. Now, whichever way you look at that, your brain will tell you that the long end is nearer to you. Now, it is nearer to you now, but now I'll put it back near my body. Now it's nearer to me, but it still looks as if it's nearer you, doesn't it? Because you're used to seeing things bigger when they are closer to you. Now, here's the spinning motor. It's simply a piece of cotton thread tied to this corner and tied to the other corner, and I've wound it around in my fingers so that when I let it go in a moment, it'll unwind, the thread will unwind, and you'll see the thing spinning. There we are. I'll hold it the same level as your eyes, and we'll let it go. Now you know that it's turning around in circles. In fact, if you look at it from above, you can see that it's turning around in a circle. But now your brain is doing something strange. It's telling you that it's not going around in a circle, but it's oscillating. In other words, it's turning part way, stopping, and then going back the other way. Now that's a strange effect. I'm going to add a ballpoint pen. And to do that, I've placed a little piece of double-sided sticky tape on the ballpoint pen. You can use ordinary sticky tape if you like. I'll place it right through the centre of the window and press it in place like that. But what's your brain going to tell you about the window? Will your brain allow you to see the window going around in a circle with the pen? Or are you going to see something really strange? It's unbelievable, isn't it? You can see the pen going around in a circle. But your brain is telling you that the window is going part way around and turning going the other way. And yet in order to do that, the two things have to pass through one another, the pen and the window. You know it's not possible. You know it can't happen. And yet as you look at it, you see them going through one another every time they go around. An amazing illusion, the Ames window. And I think you're going to have a lot of fun making your own.
Now, that Ames window is one of the activities on a DVD that we've put together called Dean and Rob's Curiosity Show Collection. And it's a 2-disc DVD set, 20 activities, runs for 100 minutes. And if you're interested, these are available out at our stand just opposite the doorway there. An interesting thing about that Ames window, somebody last year decided to put that up on YouTube. Didn't ask our permission, they just did it. But the interesting thing is, in that last 12 months, that's been viewed by 480,000 people. It's incredible, isn't it? The social media spread things worldwide. Because of this, Rob and I are in the process of working with a group of people who are putting together a YouTube channel for us on the Curiosity Show, Facebook page, Twitter page, and if you're interested in those sort of things, keep your eye open. Google Curiosity Show in the next couple of weeks and you should find the launch of our new Facebook page and all the things that go with it. Well, that's making things to solve problems, making things to fool your senses. You can also make things to explain science and technology. One of the oldest technologies that we all grew up with was moving pictures. We loved going to the movies. We decided to make a mutoscope, which is a moving picture machine, using odds and ends around the home. So let's have a look at the moving picture machine, made with simple materials. Once again, we'll use close-ups extensively to help you to see it. Here we go, mutoscope, moving picture machine.
Make your own movie picture show. Here's all you'll need. Just one piece of wood, block of wood, large or small. You'll need a cork, which has straight sides.
This was a 5-minute segment. We cut it down to about 2 minutes to show you the key points.
A drawing pin, little piece of cardboard, and 4 pieces of white cardboard, all the same size. Oh, you'll also need a safe cutter and some marking pens for doing a little bit of drawing. And here's how you go about it. You start off with the paper clip and you straighten it out. Very easy to bend, aren't they? You've done this many times, I'm sure. Straighten it out like that, and straighten it out again until it's almost in a straight line, except for that last little piece. And you're going to use that for a handle. You use it for a handle by bending that part backwards, and you can see now that I can use it as a winder. There we are, that was very easy. Here it is. And I coloured the pictures as well, just for fun. There we are, you can see the 4 pictures there on the 4 cards. You can see the little turning device, and now you see why I said you need a straight pin as well. That's so that when I turn that there, the little hill pushes against the straight pin and keeps the cork moving around in a circle smoothly. There's the other piece of cardboard, the thick card. I put that in the front of the block with the drawing pin. Now, all I need to do is to push the little cork part through the middle. First of all, the handle goes through here, and then the other end, which was originally straight, but you'll notice I put a slight kink in it, goes around there. And there, believe it or not, is our movie picture device ready to go. Let's watch it now as we check it out. There we are, first picture, pink person, yellow head, crouching. Second picture, starting to leap into the air. Third picture, leaping into the air with arms outstretched. Fourth picture, coming down again. Back to the first picture, crouching. And if we turn it around, we get the man leaping up and down. Yeah.
So that was using making things to explain an old technology, persistence of vision, moving picture machines. Now your name is? Xavier. Can you hold that plate please, Xavier? Xavier, we're going to use those things to attempt to make a model of an atom. Ping pong balls and a mousetrap. Now I hate selling mousetraps, it's so easy to catch your fingers, so I do it as carefully as I can. Bend the spring over, hold it down, put the straight piece of wire over the top and tuck it into the cheese trigger. I've done that, but can I get my fingers out of the way? One hand safe, second hand safe. Next part, take a ping pong ball with blue tack on, and I'll see if I can balance that on the spring of the mousetrap, Xavier, without catching my fingers, and I think so far so good. And then I'll do the same thing on the other side. Now some people are probably saying to themselves, wait a minute, Dean, I thought we were going to make a model of an atom. Do you mean that atoms look like mousetraps? No, but they act like mousetraps. Thanks, Rob. Whoops. Okay, we're halfway there. And Rob's going to hold the microphone near my mouth so that you can hear me. And Xavier's going to help me by triggering off the mousetrap. You see, if we had to wait for a mouse, it would take ages. Xavier's going to do it for us. Very kind to volunteer. He won't have to use his finger though, he'll use the third ping pong ball. So Xavier, hold that ping pong ball above the mousetrap. When I say go, just drop it on the cheese trigger. Ready, set, go. Whoa! The ping pong ball's flying. You can go and get the ping pong balls for us, Xavier. Now, if we'd had 2 more mousetraps like that one, thanks Xavier, come and stand next to me, haven't finished yet. If we'd had 2 more mousetraps like that one, there and there, Xavier might have hit them both, and if he had, we would have had another 1, 2, 3, 4 ping pong balls flying through the air. If there'd been more mousetraps and ping pong balls in the theatre, before long we could have had a chain
Action.
Yeah, give him a round of applause. Xavier, still haven't finished. Now, Xavier, I crowded as many mousetraps and ping pong balls in that box as I can. Can you count them for us? How many are there? How many mousetraps? 7 mousetraps, 14 ping pong balls. If we're going to set off a chain reaction with 7 mousetraps, does Xavier need to throw in 7 ping pong balls? How many? One should do it. So Xavier, I'll give you 1 ping pong ball. Now, we're going to give you a countdown from 5. When we get to 0, I'll open the lid, you'll throw the ball in quickly. If he hits 1 mousetrap, he may start a chain reaction. Okay, thanks, Rob. Okay, all together, countdown. 5, 4, 3, 2, 1, 0! He got the lot. Give him a round of applause. Well done, Xavier. Oh, I think Xavier deserves one of these, don't you? Yeah. Have fun with it. Now, on Hey Hey Saturday, on Curiosity Show, we did that with 25 mousetraps in a glass aquarium. And just for fun, I thought we'd show you the German version of that. So here's German Dean with 25 mousetraps.
Und ziele mit meinem Ping-Pong-Ball auf die Mausefalle, die sich hier unten in der Ecke befindet. Wir machen einen Countdown. Macht ihr auch mit? Von 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stellt euch mal vor, was bei einer echten Kernreaktion passiert. Nicht 19, sondern Millionen Uranatome setzen jeweils ihre Energie frei. Eine gewaltige Kettenreaktion.
Now, you might have asked yourself this question. Did everything always work first time on the Curiosity Show? Not always. It was a pre-recorded program, so we were able to correct our mistakes, but we have a few of our mistakes, our bloopers, here to share with you now. So let's have a look at some Curiosity Show bloopers.
Let's see if we can take out that bottom coin by hitting it with the back of a knife. And you can hear what's happening. It's not penetrating, it's actually bouncing off the surface. What happens though if the pin comes directly down from above with the same force? Rotten thing. Cardboard box is a very good structure for absorbing energy. In fact, if I take a heavy weight like this, I can drop that on the cardboard box and let's see what happens.
Collection of animals that really does that with armour plate. And here's a good specimen we've got in the waterhole, the yabby. Now that's a very splendid creature, the yabby. If I flick that claw, it's extremely hard. It feels like stone, and in fact it's got salts in it that are very much like limestone. And that's, of course, is what gives it its protection. But you see, as that grows, it's going to be in trouble. That's all for today.
So that's a little bit about the Curiosity Show, how we made it and why we made it. If there are any questions about Curiosity Show then or now, put your hand up and we'll try and answer your questions. We'll do our best. Anything more you want to know about it? Yes?
Do you know my name is Alex? Alexander James McNiven.
Could you ask your question again?
Alexander James McNiven. That's my name.
Oh, your name. Okay.
Alexander James McNiven.
You want to share?
speaking German is I've lost my ability to comprehend this English. I didn't catch it. What was anyone interpret?
It was just his name.
If you wanted to tell us his name, okay. There's a question up near the back. Rob, would you like to use the microphone over there?
Yeah, hello. We came in a little bit late. How long did the Curiosity show run?
18 years. It started in 1972 and went to 1990. We made over 500 episodes.
We ended up on cable in various places after that and pirate copies in Europe, but we lost track of it.
Okay, thank you, because I've been enjoying sharing my memories of the Curiosity show with my children. Thank you very much.
Please remember to Google Curiosity Show, especially in a couple of weeks' time when...
Probably more than 2, but soon.
3-4 weeks' time. Any other questions about the show back? Yes, second row. Oh, first row. What was my favourite thing that I made? Well, I think one of the favourites was the one that you helped me with, the chain reaction. In later years, after Curiosity Show finished, I worked for a few years on Hey Hey Saturday, and we actually did that chain reaction on Hey Hey with 1,000 mouse traps and 2,000 ping pong balls in a shop window in Melbourne. But it was always one of my favourites, and one of the other favourites was Ames Window. Rob, what were your favourites?
It's very hard to say. By the way, the mousetrap ping pong balls, the chain reaction is really what underlines a nuclear reaction, so we're not meant to show that in this current climate, because the North Koreans might see. It's hard to know. I have a fondness for music, so I like those. My mousetrap racer I'm particularly proud of. I say I invented it, but when I cast my mind back, I really think I pinched the idea from an American magazine. The idea, not the patent. These ideas circulate. It's one of the beauties of science. And I think it's one of the reasons that the program went so long, is that science, you know, once a spectrum, always a spectrum. Technology changes, but the fundamentals of science do not, and they're as riveting to children of your age as they were to mine and really anybody. So you've got a big advantage, I think, with science, in that the material is always there to exploit. So I think the mousetrap racer I was pretty fond of. I was very proud of getting the orthocopter to work. It's hard to know. It's hard to know.
But one of the things that I think we both tried to do over the years was to keep things as simple as possible. Taking the Ames window, for example, if you Google Ames window, you'll find there are lots of examples of it. Most of them are museum demonstrations with big contraptions this big. The reason why our little one was seen by 480,000 people, far more than any of the others, I think, was because it was so simple and so small that anybody can make. Simplicity was the key to a lot of the things we did and a lot of the things that I know you're interested in.
I won't go on and on, but probably rather than being proud of one particular thing, I think we'd both be proud of the fact that we look at television now and close-ups and extreme close-ups are ordinary, they're commonly done. We had a segment called Curio, which was just to show a very odd thing, give a couple of hints and say, what do you think it is? That was then picked up by the collectors for the mystery object. So we innovated a lot of things which now don't look like innovations, but in their time they were. We were one of the first shows to go to air in colour, so we were able to exploit all these new things. So I think a sense of changing kind of the way television was done for young people from the classroom to the intimate would be something I'd be quite proud of.
There was a question up here. Yes.
Hello?
Which one do we have? Who has the microphone? Right. Okay, what's your question?
What else is there?
What else is there? We've shared with you today some of our favourite bits and pieces from the Curiosity Show. There are 20 more favourites there. Oh, that mutoscope, the moving picture machine, that's another one that's there as well. There are all sorts of little things you can make from matchboxes. There are other optical illusions.
By the way, out on our table, it's really nothing to do with us, but I'm behind the group that's trying to bring the wonderful clipper, the city of Adelaide, back to Adelaide. It's the oldest, the most intact clipper ship that there is, and it's really ours. It's in Scotland, and we're going to bring it home. So I made a little, it's a freebie if you want. It's a pattern, and instructions that you can download off the internet, absolutely free. There's a little 1-minute video on the internet you can look at to see how to make it. It's designed for children to make a little City of Adelaide and shove it in a fruit juice bottle. That's on our stand, and you can come and just copy down the reference, go home, look it up, print it out. All you can do is ruin a sheet of A4 paper. So if you want to do more, there's stuff around, and you're welcome to do that and spread the word about bringing the City of Adelaide back.
We have a lady with a microphone and another question.
I was just wondering what your jobs were before you did the Curiosity Show.
I was originally a high school science teacher, and then for 7 years, and then for 15 years I was a lecturer at a college of advanced education, and then since then I've had my own business, media production business, and these days I speak at conferences around Australia about the future. Rob?
Yes, I really was a science lecturer at Flinders for many years. I'm not there now, but I'm attached there as a professor. Went on from that to science journalism with 10, on to Channel 2 doing Nexus, which is our Asia Pacific service, doing science for that. Broadcasting, writing books, and sort of freelancing generally. We're both involved, by the way. Anyone remember the old Investigator?
Yeah.
When the Investigator closed, 3 of us bought the assets and started it up again as SciWorld, which is now mobile. Dean's on the board, I'm the chair. We've got the Stardomes up 3rd level, and we would really love your custom if you want SciWorld to come up to your schools. Being mobile, we can go to schools, we do science fairs, and we're trying to continue this whole business of interactive science that the Investigator started. Dean and I were ticket holders #1. We have a fondness for it, and we're keeping that tradition. So quite a lot of that stuff gets mixed up in it. Some of it's paid, some of it's not, but
we're both science communicators, have always been, will always be science communicators. Next question. There's a microphone up near the back.
Have you ever built a robot?
Ever built a robot?
No, I haven't. But looking around at this fair, there's some pretty expert people I wouldn't want to try and compete with. No, never built one. I think we've had them on the show.
Yeah, we have.
Very early.
Okay, next question.
Yeah, just this quick one. Obviously, long-term shows, so there've been a lot of behind-the-scenes sort of carry on over the years. With all the contraptions that you've built over that time, have you ever done, or were you ever tempted to use them to play practical jokes on the other staffers on the set?
What, in the studio?
Yeah.
Dean!
No.
Well, I wouldn't call it a practical joke. At the time I called it self-defence. But I had one of those curio segments I was telling you about was with Flint. I'm a pistol shooter. I don't shoot animals or anything, just shoot targets, but I've done it for 50 years. But one of the segments I had on was a strange, it looks like a bit of dowel with a kind of corkscrew in the end. You think, what on earth is that for? Well, when you loaded your muzzle loader and the lead ball got stuck, you couldn't get it out. You drove this thing in the barrel, screwed it into the lead and pulled it out so you could fire it again. So I showed this as a curio, and for the props I had the muzzle loader there, and I showed how it worked. Got a couple of complaints about showing kids about guns, you always get that. But we had, in those days, a floor manager who smoked incessantly. And it's very hard when you're presenting and somebody's blowing smoke in your face because sounds like that, and I get asthma. And we'd asked him to stop many times, and he had not done so. So I got some of the black powder at my disposal, and I took his large glass ashtray and I mixed it up with the ashes from his previous cigarettes and waited and got involved in my next segment and sort of forgot. And behind my back, as he stubbed out his cigarette, there's a sound like whoom. And I looked round and a smoke ring the size of a truck tyre was heading up into and this bloke he spent the rest of the night looking reproachful and dangling his fingers in a glass of water. I thought I was going to be reported, but I must have made a point because he never smoked again and I didn't get into trouble. So that's not a practical joke, but it was jolly good fun.
I can remember something I did back in the days before Curiosity Show when I worked on Channel 9ers with Ian Fairweather and Ann North. Do you remember them? I did something with a little rocket. I said to Ian Fairweather when we were rehearsing, now this was live television by the way, I said, now I've got a carbon dioxide capsule, those little CO2 capsules that they use in drink machines. And I said, I'm going to make this into a rocket and run it along a wire into a steel ice cream container at the other end, so it makes a big bang. And he said, yeah, that sounds good. And I said, now I want you, Ian, to hold the steel ice cream container like that, looking over the top of it. He said, you're joking. And I said, no, I'm not. It'll be more fun if we do it that way. So he agreed, and I triggered off the little rocket, and it went across the studio, zzz, bang! Ian Fairweather nearly dropped to the floor in fright. But it was good live television. These days, I don't think you get away with it with occupational health and safety. I think it would have been run in for it. Next question. Right.
Better make it.
Hi. How was the OH in your day?
Non-existent. Every time we did something using a candle, we got complaints from parents saying, they burned the curtains down. Stop using candles.
I had a question asked in the House of Parliament in Canberra about one of my segments. It was a hot air balloon. It was taken from the primary science curriculum with a candle, letting it go. I was mortified. These days I'd be more robust, but you did have, it was difficult. If you take flame and you saw safety cutters, they take all those away from children. They can't build anything. So there is a sort of interesting margin to be, do you let them solder if they might burn themselves? If you say no, there's a lot of stuff you can't make. So it's a tricky one as to what you really do let people experiment with. I'm for experimentation within limits. But I don't know how we're ever going to learn to use our hands.
Wow.
We don't get access to these things.
Got time for one more question.
Yes, thank you. It's an interesting point. I like seeing it too, but I hate it when the producers who don't have any science think, oh, this is awfully sciencey, we must make it sexy, and they put people in to do silly things. As if, science won't hold its own. You've got to make it zappy and fun. I loathe that, and it happens too often. It happened to us in an inventors program we won't mention by name, where we were constantly told what we were doing was too sciencey and it had to be made more fun. It's crazy. The science will run itself, particularly for young children. They love it.
Thank you very much for coming along today and allowing us to share our memory of Curiosity Show with you. Thank you.
Put your hands together as you already are doing for Rob and Dean, and just as a token of our appreciation for them coming along, we'd like them to have a little robot made up in the 3D printing lab, which I know is a little bit out of the way, but if you do go up to the very top of the stairs and keep going around the building, you will find it, and that's where the 3D printing machines are. So again, please put your hands together for these two fabulous gentlemen. I think we need to set up for a little bit, so we'll perhaps have a little bit.
Yeah, so it's got flat surface. Turn that off. This is flat surface. Yeah. And this does it, whereas the Kinect does it in the whole room. This does it really well, and it only does hand tracking, so you can use it to control stuff. Yes.
What is that a picture of?
That's a mountain range in Scotland. But it keeps turning itself inside out. There's a plane upside down, some upside down dolphins. Turn themselves slowly up the right way. So that's where there we go, come back. So yeah, that's what it's supposed to do. So we don't know what.
He's been doing it for about 3 years now. That one's really nice. That one was made from an old wine barrel.
bazooka's very cool. Does he do much of that?
This is the first one he's made.
Okay.
And it's not for sale because it's his and he's using it.
Okay, right.
It sounds really good too.
Do you mind if I have a straw?
Doing a PhD surrounding rehabilitation using games. Yeah. And so that's like massive. And that's exactly what this is for. Yeah, right. So his aim would really be with varying issues, like varying ranges of cerebral palsy. Obviously you get some of the same as the other half. And so by forcing them to use two hands where they would normally only use one because of the fact that they're not as confident using their non-dominant hand. By forcing them to use both hands, they'll teach their brain to push forward and hopefully almost retrain, probably not the right word, but to be able to use that and rehabilitate. It's all about the therapy of trying just to get them to live life to a better level. That's what the vibrating pads are for, so that they have the visual stimulation as well as a vibrating haptic feedback through your palms of your hands. Yes.
So I see from up there, if you've got one crook hand, it can be strapped on.
Yep, yeah, you can have your hand strapped on, so if your hand isn't if you can't flatten it out, and if it doesn't sit on the controller right, you can strap it in, and so that's for more of the therapy when you're really trying to get the brain to be able to recognise this vibration that's coming through the non-dominant hand. So you probably felt that just then, like when you go off the road.
Would it be used for diagnosis? Might be the wrong word, but I guess to get a more finer picture of diagnosis, to figure out which movements they do have trouble with?
Perhaps in the future that could be used if it was dialed into a more precise movement and that sort of stuff. At the moment these are still prototypes and stuff like that, so it's quite...
It's nascent at the moment.
Yeah, exactly. We're not exactly sure what we're getting and stuff like that, but it's like, I think probably in the fact, no worries, David, good to see you. Probably, close in the future that could be something that could do, like if you had something like that, and if a kid wasn't using it properly, just click the front button. At the moment, we're specifically going towards kids with cerebral palsy because of the fact that it's with a PhD, you sort of need like the guy who's doing the PhD, he needs a scope, so he needs to know like something to get data from. But in the future, we get like kids with any disabilities to do with motor function, elderly people with arthritis. I've hooked it up to a computer with a program so you can use it as the mouse. So that's the cursor.
Yeah, okay, yeah, that's cool.
Like word processing, whatever.
Stick it on an electric bike, I can't stop you.
Sorry, what does this do?
This is a motorbike simulator. You know how in the old days you used to stick the plastic in the spokes to make the ta-ta-ta-ta-ta-ta? That's what this does, but it's a digital way. So that's a UFO effect. And we'll play with Harley Davidson in a minute. So it's sound like a real bike. But there's the dirt bike. You can buy these in about a month's time from that website. It'll be about $80 and they'll be here in time for Christmas.
my last recollection of this sort of thing in Sydney anyway, I'm not really sure what they did with it. I know that they were building Wi-Fi networks between people's computers. Is it the same thing, or is it completely different?
It is a wireless network, yeah, Wi-Fi, wireless network, yeah. And we have towers, we have aerials, we have central nodes which then connect to other nodes, and they in turn connect to each individual receivers.
Yep. So is anyone hosting internet? Is anyone injecting internet into the system, or you're all connected to each other?
They can share, as long as it's not for profit, they can share privately between themselves. Okay. So they use their network, their internet to share with somebody else, which sometimes helps if someone has a bad connection. Yep. They can share their connection.
Yep. Yeah, so I get it, as long as it's not for profit, it's kind of, it's like amateur radio,
that's right.
Same rules, right, yeah. So what sort of, do people host content on the network? What's the primary use for the private network?
There's a number of uses, yes, they can host content to each other, they can share files, they can share movies, they chat to each other, play games, online games together. So, and of course there's the other thing, we're always trying to improve the system. We have experimental things, we try out new equipment, and it's a matter, the whole thing is that we help each other, we access the site, we set up the site, we get together and set up a new site, and we're constantly expanding it.
Are you formal at all? Do you do meetings, or it's all very casual?
Oh, okay. Meeting, yes.
Right, okay.
We have one at the end of the month. We have one this month. I think it's in Para Hills. If you have a look at our website, it'll tell you, it'll give you the address and the location. We have one at Para Hills one month. They have it at Fullerton. They call it 2 months.
I'm from Sydney myself, so.
Okay, so it doesn't really matter.
Well, no, but I wonder if you also, through forums and that sort of thing, if you're all sharing ideas and that sort of thing. Yeah.
We have that too.
Yeah. The amateur radio guys. IC703. A few less buttons and whistles than the one in my car.
Elizabeth Amateur Radio Club.
Elizabeth Amateur Radio Club. How's the scene in Elizabeth then?
It is active, proactive, I should say. We've just completed the contest, for which we're usually renowned for being well and truly up the ladder.
All right, that would have been the Easter weekend contest?
Yes, the RD contest, and the John Moyle contest, sorry. And yes, it's usually a 3-day event for me, because we go the week before and set up, the day before we set up all the equipment, ready for the rest of the crew to arrive on Saturday and Sunday. Right. Yeah, there's been about 10 operators this time, plus visitors, and it was quite a good event, very wearing, but it's a good time.
How are conditions?
Conditions were excellent.
Yeah. I've got an ICOM 7000 in the car, and I was driving from Sydney, and at least one of the nights, maybe 12 o'clock, 1 a.m, dialed up to, I always forget, the 14 meg band, is that 20 metres? And that was absolutely going off. All the US stations, I'm sure there were UK stations coming in as well. Clear as a bell, it was great. Although a couple of nights later didn't hear anything.
That's right, the band opens and closes. Yeah, so it's all good fun. That's the only one I've got in the car at the moment, so that one's 7. I run an amplifier on that, so it's equivalent power out to you.
Okay. Well, I'm still on my foundation, so I've got the dials turned down.
Good boy. Are you studying for your
I should be. I've only just been given the heads up about there's a good online resource, but it's paid for content, but it's a kind of a training tutorial thing for your standard license. Sorry?
Worth doing.
Yeah, yeah.
A couple of guys in the club have done it.
I can't remember what the website's called, but another guy that I did my foundation license with was recommending it, and so because I was talking to him and I was going, it's about time for you to renew your foundation license, right? Because it was the same time for me. And he's going, no, I've already gone up to my standard.
We do chase you, you know.
Yeah.
Away with it. It's good fun, but don't let it lapse. You'll get there. There's no time limit.
With
take your time.
Going, yeah.
I mean, no, for you personally, there's no time limit on when you should do it. When you think you're ready to do it, do it.
Yeah, well, it may be that I'm ready now, but I kind of, have that. I'd rather go in there and, not that it really matters, but feel confident, get a decent score, rather than, scraping in with 1 point.
They're fully committed.
Yeah.
That seems to be the answer, being fully committed.
Yeah.
Those who do it that way tend to get through first. That's a noise eliminator. On the screen, you'll see atmospheric noise along with the audio content. At the top,
Must be football or something.
you'll see the audio only with no noise. It's done by using 180 degrees phase shift. Not very much filtering in it at all. Only one high pass filter. And that is no filtering.
And all analog as well,
That one there, yes, all analog.
That is one nice thing with the ICOM 7000 is some of the filters, some of the stuff that just can't quite hear properly, and twiddle a few knobs and comes in clean.
I used one on the contest. I didn't use mine. I used one of the other guys. I had a chance to fiddle with it during the contest. It was worth it. Good stuff.
It feels like cheating with all the DSP digital circuit stuff, but but when the signal comes in strong, you kind of forget about it.
Well, that's right. And that one there is a repeater controller.
Oh, okay.
That one, if you've got two transceivers, you can turn those two transceivers into a dedicated repeater. Either the same band, slightly different frequencies.
Plus or minus 600. Well, for UHF,
that's right. You can do crossband.
So,
VHF, UHF, HF, microwave, whatever you like. Any two radios on there, you can make one go to the other, vice versa. After you flex, it's the same as the rest of the repeaters around Adelaide. It's got full timing facilities in it. There's a 10-second delay time. So take care of the button pushes and interference and stuff, so you don't get IDs all the time. There's voice ID, not Morse code.
Okay.
And there's two memories for that. One would obviously be the station ID. The other one could be an advert or anything like.
All right.
Then you've got another timer in there that gives you an ID in 10 minutes time. Well, 9 minutes 45 seconds. To sneak out of a 10-minute recording. And you can do that. That was done mainly because of cost benefit. So I can go VHF when we're having a net in the club, and we want one of the club members going around with his four-wheel drive. He wants to be in on the net.
Be part of that,
in the middle of bloody Queensland. So there's that.
Yeah, no, it's good.
Radios, plug them in. It's a box operator.
Okay.
So only talking audio, push the talk microphone. That's it. Any two radios on whatever power you like, and it can go from DC to light, microwave, whatever you want.
I haven't heard many cross band
repeaters. Well, you won't hear many like that one.
No.
it's the first time, to my knowledge, it's been done.
Oh, okay.
To make it that flexible.
Okay.
So you could use it for emergency services.
Yep.
If we have a national disaster,
yep.
You could have maybe the fire brigade on one and the SES on the other.
Yep, I got you.
So they can patch their radios in there. They can talk to each other. Vice versa.
Was this built from designs found elsewhere, or was this sort of club
The
design?
original idea came from a 73 magazine back in the 19...
All right, yeah, I've heard of 73 magazine.
1960 something or other.
Right, okay.
That's where I got the original idea from. I've expanded it.
Okay.
So, and of course, like all good things, that's all it ever started out to be. It was just a simple demonstration repeater.
Right, until
meant to do two handhelds and nothing else, just that, just for fun and just to show people how to fiddle. But waking up in the middle of the night thinking, that worked well, I'll do something else.
Yeah.
By the time you're through adding, you end up with a spaghetti farm.
But it's a beautiful spaghetti farm.
Oh, of course it is. It took me hours to create that. G'day, Andy.
G'day, John. Good to see you. You're the king of home brewing.
Oh, at the moment, yeah, I've been bloody thrown out.
What I would like you to do is have a look at the front of your card and think to yourself, maybe I would like to have an LED. And once you figure it out, tell me and I'll roll it for you.
People use it for squid jigs.
Oh, okay.
Yeah, you can get sick of no catch any fish with it, make another one. Or the plastic friendly colour, so a bit like this sort of hard, like that. And the same thing, you melt it down and then you can remelt it. So
that's got a little bit of flex, that would be alright.
And that's not fully cured either.
Okay, so it would become a little stiffer than that.
Yeah, and that one's probably
something rubbery would be better to my purpose.
Yeah. I mean, the hot ball item is quite floppy.
So, sort of like some of the silicone?
Yeah, probably a 2A and probably about a 12 or something like that.
Doing one of these properly, you'd be using synthetic bearings and all the mechanical bits you might separate from the heat engine side of it and pressure lubricate that also keep it oil.
You built yourself?
Yes.
Do you do much boiler making stuff as well?
No, I'm more of a if it's on the kitchen table I'll make it.
All right, yeah.
I do a bit of engineering, but mostly at this scale.
Yeah. Any other fun things like this?
This is a commercial program, but I can't divulge too much. It's a first flush diverter for rainwater, which is adjustable.
Okay.
Over quite a range with a self-cleaning filter.
Okay.
It's all powered by water.
Yeah, that sounds interesting.
That's commercial though. Working with a company, 4.5 years at it.
Okay. Yeah.
Haven't prototyped it yet.
All right. Sounds good. Did you ever see the? I wasn't quite sure how viable it was. I think it was on TED. I don't know if you're familiar with the TED Talks or TEDx Talks. It was anyway. They're just talks on things. And he had a solar-powered Stirling motor.
Yes, it has been.
Whoop.
That's okay, mate.
It's been happening all day, hasn't it?
This one normally used to have a mirror attached to it.
Okay.
And this was built in 1978.
Oh, okay.
And it was demonstrated back then.
Right.
And basically, you're breaking the rules. You're allowed to. We get at least one start after every hour.
I can sit and watch it go for hours.
Yeah, it's almost as
I'll start to make one. I've already got some nice big cans and aluminium.
Yeah, you would do something like that, yeah.
I got nothing to do.
So I think this guy with the solar Stirling engine was talking about for homes, putting it on rooftops. I wasn't quite sure about that. I wasn't convinced, but
not convinced.
No.
The one that did convince me is the version of the Stirling engine, which is called a free piston engine. A lot simpler. You couple it to a linear alternator. The whole thing ends up in a sealed capsule. So you've got no audio wires coming out. Sealed wires, highly pressurised helium inside.
Right.
Solar dish. We're looking at efficiencies of 40%.
40?
That was prototyped in the 80s.
Right, okay.
I don't know where it went.
No, okay.
But you had to have a tracking. Parabolic mirror.
Yeah.
That was taken to an extremely high level of sophistication and development. And as far as I know, never went anywhere further.
Right. Now, I've only seen on YouTube a few pictures of installations, and usually, somewhere out in a rocky desert, of Stirling motor arrays, solar Stirling motor arrays, and they all seem to have that scorched scoring, around the focal point as well.
Well, the one on this has got a it's pretty heat stress.
Yeah.
It's a stainless steel pan with a glass front, and it's got rock wool in it, and the rock wool is just full of pock marks, and it's yellow at the back and highly white and stressed at the beginning at the front, and sort of starting to defragment.
Lots of fun. Thanks for chatting.
Thank you. Steam going into a steam. A bit of air going into a stick of air. Air moves it around the side and around between hot space and cold space. No water. No water. That's pretty cool. It was invented in 1816. They are generally more efficient than steam engines. Why weren't they used? Why didn't they use? They were. But I think steam engines are more forgiving.
Okay, we don't do it anymore.
So that would have been made. What was that whole gem?
I remember it. First took us there. If you did want to come take a picture of that,
So I wondered.
That was funny.
I can see it.
It's got a picture, it's got an automaton, there's a table.
Alright, so tell me when.
Yeah.
Oh, it's okay.
Watch the top bit.
Oh, okay, alright.
If you like, I'll show you.
Oh, I'm on the line there. Lucky and New Love.
Got nothing to lose.
Could have been worse. I'm not sure what the other cards
I'll show
say.
you inside.
Yeah. So with the cams, you've had to sort of sit there and figure out what shape they need to be, and
It's not.
or is it a little bit?
Science.
No.
Just try. You can do it with cardboard first if you want. I just they're very simple movements, just like a show. Sort of thing.
Yeah. Okay. Yeah. Okay. That's a good description.
Oh, no!
Thank you. You know, I don't really have a title for this talk. We put it in as Cheers to the Makers, which is probably why, you know, very few people decided to show up. But, you know, I just wasn't asked to speak about anything in particular today. So I was just thinking about what to do. And the Maker Faire, the main Maker Faire is known as the world's biggest show and tell. So I thought I'd just show a few things, some of my things, some other people's things, and tell a few stories. So just have a bit of fun. But first of all, just like to toot the horn a little bit. Hope everyone's had fun today at the Maker Faire. It's pretty huge. I'm really impressed by how much stuff we managed to turn out here in Adelaide. So that's great. And here in Adelaide now, of course, we have the first MIT-affiliated Fab Lab in Australia. And you know the motto: think it, make it, share it. So that's what we're here to do today. And we've also got a hackerspace. Those guys are great. I hope you've seen them upstairs, Hackerspace Adelaide. And now this mini Maker Faire. It's only the second one ever in Australia, and hopefully we'll do it again, and it'll be the first one to recur. So I just wanted everyone to give a quick round of applause to the people who made this happen. Annette, all the sponsors, especially the Feast. So let's give them a little bit of a round of applause. Because people really worked hard on this. It took a lot of effort to put it together. And that's an important part of the share it part of the Fab Lab's motto. So I wanted to start off by saying a few things about you know, the maker movement, as some people are calling it. I begged them to, even though I wasn't on camera for that second, I begged them to let me shoot it in one of the segments. When are you going to go to town?
Can you make 10 rounds of singing with him?
Well, thank you for sticking around. This is going to be a panel session which is about the topic of will all thumbs and no hands make Jack/Jill a dull, non-creative adult? And the genesis of this is really to challenge people's ideas about both virtual and physical making. There's no correct answer to this conundrum. But we've got here some fairly passionate people who will probably be able to take one or other of the sides. But first I better introduce the panel for those people who have not been in the auditorium for the rest of the speakers. There is one person who has not spoken so far, which is Mark Thompson from the Institute of Backyard Studies. He's the one who's had the smoke ring gun out the back. Sorry, Mark, the vortex generator. You must see it if you haven't seen it already. It's outside around the back, so definitely go and see that. Very happy to have Mark on the panel. He's also been one of the organising committee members. Of course, you've just seen Zoz Brooks, MIT graduate, television superstar, both a virtual and physical maker. Then we've got Rob Morrison, who needs no introduction, again, passionate about physical making. Fee Plumley, a virtual techno evangelist.
I'm a real techno evangelist.
True enough. A real techno evangelist. Alan Noble from Google and Genevieve Bell from Intel. So, this is going to be very. I really haven't had a lot of time to think about how this is going to work. But I guess what I wanted to first ask is what people think about the virtues of physical versus virtual making. Do kids need to get their hands grubby with physical objects in order that they can get that sort of creative spark? So, who wants to go first? So maybe we'll start with Genevieve and we'll just pass it down the line. So,
I'm really tempted to just say, are there any of us here who disagree with the notion you should get your hands dirty? No, I didn't think so. So you'd like us to make an argument anyway? Okay, good, we can do that. All right, so...
Well, we should define what you mean by getting your hands dirty.
That's a fair point. What do you think you mean?
I think the key thing is to basically do something. And whether it's physical or virtual is less important than actually is creating and building and making. I mean, that would be my view on this. I mean,
I completely agree with the last two opinions. I'm actually going through a bit of a transition stage at the moment because I've been, I used to be a prop maker and a stage designer and used to work in theatre. And so I made physical things, and I was a crafty tinkerer, and I always made stuff physically when I was a kid. And then I found technology and went, oh my god, the internet's amazing, and then completely moved into that as a space. And then sorry, my phone's ringing. Go away. And then I ended up spending so much time working in the virtual environment, working online, working with ethereal experiences that you don't get to hold and show someone afterwards. And I loved it as a space, but I think now that I'm going back to making again, because I was a producer and a facilitator for a long time in the middle. Now I'm going back to making again. I'm knitting and I'm sewing and I'm making physical things that don't always have anything to do with technology at all. And I really do think that you need both. I think you want to play in messy spaces that get you physically dirty and that keep you physically active. But then you also want to be creating spaces and environments that more people can engage with because they're online or because they're mediated in some way through technological interfaces. But as long as they're meaningful experiences, it doesn't really matter whether they're physical or digital. That's what I think, I guess.
Yeah, thanks. I think we don't want to be preaching to the converted. I think most of us, if we're here, we do believe that getting your hands dirty and doing stuff is important. The question is why, and I think there's some obvious reasons, and some of them have been dealt with here, but with the Curiosity Show we were dealing with 10 to 13-year-olds, and it's quite an interesting age. A lot of their parents, when we were doing this sort of making and doing stuff, would come up and say, oh, you're so lucky to be able to use your hands, and you'd look down expecting to see a bloodied stump and a perfectly good hand. But it's up there something had happened. They hadn't done it. And it's like kids who let mathematics get away from them too early. Suddenly the shutter comes down and they now think of themselves as somebody who can't do it, and all these barriers are there. And I was blessed when I was at school. We had in fact he was the father of a premier, Charles Bannon, who was an artist. I don't think he was a wonderful artist, but he's a tremendous art teacher. And he had us as kids beating, heating up metal and beating up blacksmithing and making copper stuff. He only did it once. But at 40, you look back and you say, I can do that. I can do that. You did it then. And I think the kids who don't get making and doing early and get it into the fingers, there's a barrier that builds up that says to them later they can't do it. And it's really silly. I can fix watches, but I watch my wife doing needlework. She's a textile artist. I try and do needlework. It looks absolutely crap. For some reason, I've got a barrier that says I can't do neat stitching. I can do it with copper wire, but I can't do it with... They're really subtle barriers that you really you know, they will erect themselves unless early enough you get the experience that says up there, I can do that. It's almost like an immune system reaction. So I think it's crucial, and I think it's crucial early. And the other thing is, kids would watch you make something. Sorry, I'll be very quick. Well, I can't. I'll be very long. But I'll be as quick as I can now. But we would make these things on the show and always show that they work. And kids would come up and say, I made that play, it didn't work. And they'd sort of have one go at a propeller. They had no sense of materials. They'd get a bit of foil and twist it at right angles and wonder why it didn't drag the thing through the air. Or they'd grab a bit of wire that you set to bend, like a paper clip, you know they could bend. They'd grab fencing wire, they couldn't bend it, so they'd give up. No sense of materials, nothing in the fingers that says, that's the foil I need, that's the twist I need, that's the wire I need. You watch farmers, they can make anything out of wire because they've always had to do it. It's in the fingers.
Yeah, this is a topic that I could rant on at length, you know, on many different aspects. But on this one, I'll concentrate at first on the improvisation and hacking stuff that I talked about. Actually, you know, making things, it fundamentally changes the way that your brain works. It's true. It changes the way that you look at problems and how to solve them. And there's a fantastic TED talk on the failures of science education by this guy. I can't remember who it is, but an English guy. Probably that's the one I'm thinking of. And anyway, so not to embarrass my my most recent alma mater or anything, but he goes to MIT at graduation and he asks students some questions that show sort of fundamental understanding of things. And so he asks students, one of the questions is, if you've got a battery and a light bulb and one wire that you're not allowed to cut, can you light the light bulb? And according to him, like 75% of people can't answer it. They say, no, you can't. You need two wires because you've got to make the circuit. Well, they've obviously done lots of circuit simulation stuff and all that kind of thing, and looked at circuit diagrams, right? Which are tricky because the wires on the circuit diagram aren't the real wires in the real world. And you can touch the light bulb to the battery and you don't need a wire, right? But so if you've spent your time looking at the, you know, one side of things, the theoretical side maybe, or if you his point is you've spent all your time looking at pictures of things instead of the real things and fiddling with them, then you see the whole thing in a completely different way. So I'm going to sort of twist this question around a little bit because I think we're all, you know, on the same page when it comes to the importance of physically making things. My question that I'm going to raise, and not to you know steal thunder from the next person, we can think about it maybe and then come back to it, is the difference between specialized and general purpose tools. The problem is that when all you have is a hammer, everything looks like a nail, right? To use an example of a general purpose tool. So if all you have is a water jet cutter, pretty soon you're doing totally aberrant things on the water jet cutter. Like we did even on Prototype This, right? We said that we need this many steel parts for the water slide simulator. So I'll lay them all out in the water jet software and we'll put plates of 1-inch thick steel in the water jet, we'll just feed them in and out will come the parts. A whole bunch of those parts were triangles. And it took someone to look at this and say, look, wouldn't it be better to just get a piece of bar stock and cut the triangles off it by just, you know, changing the saw blade around? Yeah, it would, but you know, I was focused on laying everything out in the water jet because I had the CAD files and I was doing water jet layout, right? So the question is, thought experiment. This is an example from a friend of mine who taught the demining class with me, the landmine removal class. Your task is to design a piece of equipment that will cook the yolk of an egg, but leave the white liquid. And so you think about how you would design this piece of equipment, how you would do it, and then the next thing is you have to be able to make and sell this like egg inside out a cooker thing for under $1. And I'll give you the answer after you've had a chance to think about it.
Thanks for that, Zos. I'll try and think about that and talk at the same time. I'm tempted to rain on this parade a little bit. And I think when you're looking at the differences between the virtual and the physical world, I think back to when my daughter was 16 and just started to go out and go to parties and drive around with boys and cars. And one of her friends had a problem at a party, her 18-year-old boyfriend in a very high-powered sports car got very drunk, and my daughter's friend had to drive the car, and people said, "You can drive?" She said, "Yeah, I can drive, no problem." Got in the car, turned it on, went to the end of the street, went straight through the fence into the house, right? And went to hospital, quite severely injured. And when a friend said, what happened? She said, "Look, when I did it on Xbox, it was perfectly fine. You know, I can drive really well on Xbox," right? And so I think it really comes back to something really that Rob says, that the physical world has a materiality and a tangibility to it that how that marries up to the virtual world is an incredibly complex question, right? And I think how those two things, and that's what I love about the stuff we see around here today, is that they are on this incredibly broad spectrum between the physical and the virtual, and all the millions of permutations that are possible within that, right? And so I'm a little wary about that, you know, in championing the virtual world, all I can say is that it has always been a physical world, and I think there's two words that we've got to think about here: climate change. Because climate change will be the great challenge to human resourcefulness, you know, that we haven't seen the likes of for a long time. That's my personal feeling, my gut instinct, having looked at these things for a while, that this will challenge us like never before. And I am hugely optimistic about how we are approaching how we are enlarging our attitudes to technology to allow the maximum resourcefulness of our own capacities. So that's my thoughts about it.
I guess one of the issues has been that perhaps our school sector is not encouraging enough of physical making. Does anyone have a comment about that, or a solution? Do you agree with that comment?
I just want to quickly lob in my great friend Joe Grannon from Prototype This, because he learned how to drive from playing pole position on the Atari ST. It kind of shows.
I just want to do my rant about education, because you've given me the opportunity, and you know, any opportunity to rant is a good one. The thing that drives me insane about the education system is that you're told to sit down, shut up and do what you're told, and go through a series of very prescribed processes, most of which are eternally dull. And then you get to, if you're lucky or you choose, you go to university, and then you get to either a foundation course when you're supposed to be a self-directed, creative human, or you go to a PhD or some kind of research-based education. And you're supposed to be able to lead yourself through these processes. But nobody ever teaches you how to lead. Nobody ever teaches you how to be independent and self-responsible. And then you leave school or college and you go and get a job, and you're supposed to sit down and shut up and do what you're told by your boss. And you're also supposed to be assertive and be thinking of things that are opportunities for the company. And again, it's this whole kind of difference of this insane juxtaposition of freedom, confidence, independence, productivity, creativity, versus keeping your mouth shut about the system that you're in because it's dull and it's boring and it's stupid and things don't work properly. And then the people that we aspire to, the kind of Steve Jobs and whoever, the people who are actually out there doing amazing things, and everybody goes, wow, we should all want to be like that. And you're like, where in any of these processes do we get the opportunity do we get encouraged to think outside the box? Like, you can't have it both ways. You can't tell people to sit down and shut up and then be amazing at the same time. You've got to experiment. You've got to learn. And the only way that you learn is by failing. So we should be teaching people how to get it wrong, because that's the only way we're ever going to get it right.
This is a fundamentally important question which could take the rest of the afternoon, especially if you don't get the microphone away from me. But for a couple of different reasons. The trouble is, people say, oh, it's school, they don't teach it probably at school, but it's much deeper than that. There are actually two ways of learning that we've lost track of.
And I'll get a bit technical, but it's really, I think, really important when you're talking about science and technology. Induction is the process of, you take a lot of isolated instances and you say, aha, there's a common thing here. All these animals have beaks and feathers. Aha, they all related. We'll call them birds. That's the process of science, to go from all these particular things to a fundamental principle. The process of technology is to start with the principle. So you tell me the principle, I can make something individual out of it. So you tell me the laws of electricity, I can make a radio or a... Now, the investigator, which some of you would remember, and we've taken over the investigator's assets, we're now SciWorld, is trying to persist with this inductive process of you fiddle with it and see what comes to mind. The trouble is, it takes a lot of time and you don't know where it's going to go. For that to work, you need somebody who really is confident about their science, who can look at a kid coming up with all sorts of hypotheses about what they're seeing and sort out the good and the bad and the productive from the unproductive. You need a lot of confidence and some ability to be able to do that. We haven't got enough of them. The other thing is it takes time. If you give a kid a whole lot of these things and say, see if you can work out the principles, they might spend all day on it. In the meantime, a whole slab of the curriculum is meant to have been covered. So you are forced back into the deductive processes of, let me give you the principle and you do an experiment, and if you get it wrong, you're wrong, because this is the principle. So we're forcing people all the time into the deductive. There's an inherent wish to learn things inductively. Men will not look at the instruction machine when you give them a bit of an appliance. They'd rather fiddle around with it and make it go wrong than look at the instruction booklet. That's inductive learning. Women too? Oh, okay. You show a kid a new game, they say, oh, don't read the instructions, let's play a few hands and see how it works. They like the inductive. We like the inductive, but we force the deductive on ourselves. And it's partly, I think, the time constraint of having to deal with a certain amount of stuff in a certain amount of time. And fiddling at home can teach you patience. If it's a hobby, you're not constrained in that way.
I mean, another way of thinking about it, if you've got an idea, no matter how, if you're young enough to have an idea, you're probably young enough to think about what you might do with that idea and where you might take that idea. So I'd like to make sure that, we introduce essentially a bit of an entrepreneurial culture as early as possible. I was thinking about these comments about making and the physical versus the virtual, and I'm a little bit worried about making too strong a distinction. I mean, I'm a software engineer, and I was asking myself, well, software, what is that? Well, it's bits and bytes and photons and electrons. Yeah, sure, it manifests itself through a hardware device like a computer, or it might control a robot, but the software itself is about as virtual as you get. I was thinking about my daughter who's studying character animation, and yes, she's an artist, and occasionally she actually does paint, but for the 99% of what she does is, again, virtual. She's designing characters on a computer, and those characters and those stories are, again, they manifest themselves through various devices. And so I think we have to be careful about, I do think there's experiences to be had in physicality, but I don't think, there's anything wrong or shameful in just creating things that are not physical, because a lot of what we do these days at its core, and I come back to software again, at its core, it is not physical. Yes, it controls physical devices, it interfaces with physical devices, but the software itself is not physical. And so, yeah, I just wanted to throw that out there. I don't know if anyone else has some comments. I think Jenny does.
And I guess I want to push back again on the physical virtual thing, partly because I think we always run the risk in this particular community of making a fetish out of making. So the physical becomes this incredibly celebrated thing because we're course correcting, and we recognise that, right? This is a course correction against certain kinds of things, and I think at that point it is reasonable. And we, at some level, in multiple countries, there are, I wouldn't say rational, but there are known reasons why education has gone the way it has. It's about mitigating risk. It's about insulating schools, it's about teaching to the test, it's about notions of what a curriculum looks like, and a whole lot of things got thrown out as that happened. Turns out physical making wasn't the only thing that got thrown out. The other thing is the thing I would suggest is the other virtual, which is theory. As much as we may not teach making, we don't teach as much critical thinking as might be necessary either, right? And so for me there's a piece about the virtual that isn't about structured virtualness. It's not about what is made in the virtual to recirculate. It's the moments you get to have that we would think of as thinking, as imagination, as play, of all the things that arguably, because all of us on this panel, except obviously Fee, are old, you know, maybe not Zoz, you know, no sweetie, oh bless, funny, pat, 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 good. Is that, you know, we're all of a vintage, and many of you in this room are too, right? We're all of a vintage where for the most part in the places we grew up, there was a moment in the summer when our parents, mostly our mothers, kicked us out of the house and said, come back when it's dark. Does that ring a bell to anyone? We all got kicked out of our houses. And we went, Mum, I'm bored. And the answer was, how bored are you? You could mow the lawn then. We were like, we're not that bored. And we went and found things to do. And I think there's something about that notion of, it wasn't about purposeful making. It wasn't necessarily about you need to know how to do a thing. A lot of it was what happened in our own heads. And there's something about that notion of the virtual that is about thinking, it's about willfulness, it's about imagination, it's about a whole lot of things that don't get said, that may not even ever be shared with another person, that just live in your own head, that are also things to be sort of actively encouraged on the one hand. And the second hand for me is, as much as we talk about making and we put a value, a good one, on the notion of physical objects, I think we are very remiss if we don't also know that there are questions we need to ask about that are questions that only come out of not making but thinking. And there'd be some obvious ones we might ask about this panel now. Why are there only 2 women on it? Why were there very few women speakers in an entire day? Why is much of the making community looking like that end of the table, not this end of the table? What is it about the nature of making that seems to have a genderedness to it? What is it about making that means it looks different in emerging economies versus...
Oh, very excellent question. So what do you think?
Patriarchy, I think, is actually fairly straightforward. I think there are reasons about... don't even get me started, Mark Thompson, we can have this fight. But unless you're also willing to ask the questions, you don't get to an answer. But I mean, there are structural answers to it that have to do with school curriculums, that have to do with basic parenting, that have to do with the continuing assertion of certain kind of gendered roles. So men don't look at instructions, women read instructions. That reinforces a set of practices that make certain kinds of activity okay and not okay. And consciously we can all look at the talks we gave today, and I'm going to pick on you. You gave a lovely talk, it was beautiful. Did you cite a single woman in it?
My bad.
Every time one of us gets up and does that, we reinforce the image of what it is to make. Making becomes the moonshot. It becomes every captain of the Starship Enterprise. Except one, yeah, didn't cite her. You know, there's a whole, you know, it becomes Kennedy, right? All of which is fine because those are inspirational moments, but there are a whole lot of women who were makers who did amazing things, who would be incredibly inspiring to listen to. And unless, you know, we add their names, every time we give the roll call, every time we talk about it, we have them as the examples in our slides, in our talks, in who we put up as the people that we celebrate. It makes it really hard if you are a young person looking at that and going, oh, there's me. Same with if all of our makers, the other thing we might look at this panel, not exactly ethnically diverse. And, you know, we had an Indigenous person cited earlier and no one could pronounce his name properly. Not good if you want to talk about David Uniapan and you can't pronounce his name, and he's Aboriginal and he's from here. So there's something about if you don't include in the stories that we tell ourselves and the actions, all those other moments, it makes it really hard to move past this. And that's just not about making, right? That's about the stories we tell about making. So there, more women made.
Can I jump in?
Totally agree, by the way.
I think that leads nicely into sort of a segue about this, how obsessed Australia is with innovation, yet a lot of the government rhetoric is that this is all just tinkering and artsy, crafty stuff, and is actually not relevant. It's not industry. What do the panel think about that? And is there any way that we can correct the course of public policy around this?
I've got the mic, so I'll start real quick, and I want everyone to say something on this one, because this is a really, really important subject. So Australians are amazingly rapid adopters of technology. That's good, but it's also bad. I mean, in fact, if you look at, say, smartphone adoption, I believe we have the second highest, per capita smartphone adoption, second only in Singapore. Same with tablets. There's a long, long history going all the way back to, agriculture technology, where we've been good adopters. So clearly, Australians get the value of, innovations and technologies. where we're failing is in the creation and the production of new technologies. So I think we have, well, there's probably many things that are lacking, but one thing that's lacking is we have an awareness problem. And this starts in school, it starts with parents. It's amazing how many times I chat with parents and, you know, I ask them what little Mary's doing and they say, oh, you know, she's going to be a lawyer just like me, or, you know, or little Johnny's going to be a doctor just like, you know. It's like, well, have you encouraged, you know, Mary or Johnny to kind of study something else, you know? And it's like this failure of imagination to imagine, you know, other things that might be possible. And I think, you know, it starts at a very, very early age. And I think, you know, government can also be accused of, you know, failure of imagination too. But it's not just government. It's Australians as a whole seem to be unaware, in a sense, that there are these wonderful opportunities. I talked about moonshots, but, you know, there's you know, we can change the world for the better. We can make sure that climate change doesn't destroy the planet. I mean, yes, it's a huge challenge, but there's some amazing, exciting opportunities, all of which will require, you know, a generation that are comfortable with theory, problem solving, making, building, innovating, all of these things we're talking about. I said I was going to be short and I haven't, so I'll pass it over to Fiona.
Well, yeah, but if you say you're going to be short, I'm not. So, makers are invariably independent people that just get the fuck on with it. They can't be bothered waiting for someone else to come up with something that works. They just want it to work, so they make it work. They tend to not be particularly shouty about who they are and what they do, and they're certainly not doing it for any particular profit. So they don't hang out in the circles that are the ones who have the ear of government. So if we want to change policy, we have to go and be really annoying at government. We have to remind them that there is another way. We have to take that responsibility. In the same way that we want this thing to work and it doesn't, and so we find out how to fix it, and then we fix it, and we go, yay, look what I did, that was really cool and nerdy. We need to do that to government. We need to go to government, rather than say, you are not listening to us. We need to go, you are not listening to us, and we think it's because of this, and we think that you need to understand this about us, and therefore this is what you can do to fix it. Because that's what we do, right? So why aren't we doing it with governments? Why are we expecting them to fix our situation? Because they can't. They don't understand it. They don't know who we are. They don't come out and hang out in our sheds and see the amazing stuff that we do. They don't come and hang out on my bus, although I might start inviting them. I've got a friend who works for federal government at the moment who is a change maker, and it's really exciting what she's planning on doing. I can't tell you any of it, unfortunately, but she's doing exactly this. Like, her view of the government is, or government generally as a thing, is that they are there to service the people, and so when the people don't tell the government that it's wrong, it's not really their fault they're getting it wrong. And so what we need to do is be more vocal about it, but help them to change what those systems are going to be. And she also thinks that law should change if too many people are becoming illegal, which is quite an interesting premise. So, like, if we actually start looking at why we're breaking lots of laws and what that means to society, maybe we change the laws, not blame the people. And without much more of this thinking and this public dialogue, yes, awareness is important. I mean, that, you know, mini Maker Faire as a thing is all about awareness, right? It's all about bringing people out of their sheds and physically putting them together in a space to go, wow, look how much amazing things, how many amazing things are happening in all these little quiet spaces. So we need to bring much more of that out, and we need to be much more responsible and active in going to the people who should be listening and making sure that they hear us. It's our fault that we're not being listened to. It's not theirs, as sad as that sounds.
Not sure I entirely agree with that. I agree with part of it, but you were sort of lumping creativity and, I think, probably paraphrasing wrongly, entrepreneurial skill, how we're short of those. We're not. Australia has, per head of population, more inventors than almost anywhere in the world. But invention is not innovation. Invention
to turn innovation means you've got to find some way of making that invention work in the marketplace. And we're not good at that. I was for many years the patron of the Canberra Inventors Association. I'd watch how people go over to Switzerland and come back with gold medals. They didn't understand that $1 spent on invention means 10 in development means 100 in marketing. They would mortgage their house to do the development, end up with a fabulous prototype, and that's where it would die. And our model in Australia, I think, is wrong of how we invent and innovate, because we leave it to these people to do exactly what you say. They get together and they come up with these fabulous things and wonder why no one takes any notice. And I've got a lovely book at home. It's an Edwardian book of inventions. It's full of the most extraordinary things. A bloke who invented a grand piano that would double as a trampoline. A wonderful wire device that I actually made for training children to hold their fingers properly when they write. Fabulous things, wonderful ideas, which of course die because they just couldn't find no place. And what I would love to see in this country is a totally different model, and I think the model was the space race in America. Kennedy came out one day and he said, to everyone's amazement, in 10 years we will have a man on the moon. That's it. And bring it back safely. And all these technologists said, that's bullshit, we can't do that, we have no way of doing it, we don't know how to do that at all. But it was a matter of national prestige and priority that they did it, and they did. But what they also did was to invent carbon fibre, to invent hand-powered tools driven by a battery you could use in space, to invent little computers you could use in your desktop, invent all these things which sat there as this huge quarry of ideas and materials that everyone else could come in from sideways and take. Americans complain about the cost of the space race. What they should do is to add up what they've got out of the patents on carbon fibre and Teflon and all these other things, because the world goes to them now to raid this quarry. And what I'd love to see us do in this country, we probably did it once with the hydroelectric scheme, Mount Snowy Mountain, where we had this big project, that he had to invent all sorts of new ways of doing things that created technology other people needed. I saw it done in a miniature way a few years ago when I think Bob Hawke said we'll have the Billion Trees project. Within 2 months, somebody had invented a seed sowing machine you could tow behind a tractor, would spread all these seeds out. So I would love to see somebody come up and say, in 10 years' time, we will be able to fill in the dots. Might be take a little country town that's dying on its feet, make it totally self-sufficient for power, for water, for effluent disposal, for all things. Have no idea how to do it now, but if you made it a matter of national priority, we would find the ways and we could flog it to the rest of the world, because we'd be marching in the same direction and using all our wonderful inventive and innovative skills into something that A, would pay off, which the space race didn't in getting to the moon and back, but also creating stuff that the rest of the world needs. It would be a recipe for a gold mine.
Can I just interrupt there? 3 words, National Broadband Network. Might need a bit of invention around that, I think. Soz.
Yeah, I feel completely unqualified to talk about why governments do the things that they do, because, I'm an engineer, I'm a policy guy, and there seem to be precious few of them in the government. Just to comment on the moon race, I mean, when Kennedy said what he said, he didn't say it because it was an issue of science or technology policy. He said it because it was a proxy for a nuclear war with the Soviets, right? This was about, all right, they put a guy in orbit, we're going to show them that we're the big dog around here, and we're going to scare them. And so, the rationale behind it is just completely alien to what's actually supposed to be happening. And so, the first thing that I thought when you mentioned the question is there was this old poster called Murphy's Other Laws, and one of Murphy's other laws is 99% of everything is crap. And yeah, right, 99% of everything someone's going to make on a 3D printer is going to be plastic, useless crap that's going to get thrown away, or the baby is going to play with it for a while,
Something Christmas crackers.
Right. And you just have to accept that, right? There's just no getting around that. The only way that you can optimize the situation is to make sure that there's a big 100%, so that the 1% is serious, right? 99% is always going to be crap, and the government people and everyone just needs to understand that it's just about making the pie bigger. And so I think there's a lesson for us in that doing things like the Maker Faire and stuff like that is that we can't be so self-satisfied in showing off the best stuff ever that we turn people off because they don't think that they can compete. There's this Kurt Vonnegut quote where he talks about artists and how globalization, makes things very difficult because, and I'm just going to have to paraphrase the quote, but it's something along the lines of, someone who would have 20 years ago been a community treasure now has to compete with the best in their field in the whole world. So that's the flip side of what I was talking about the globalization of community. There's so many advantages to that, but there's also disadvantages if it's phrased as a competition, because someone is not, there's only one person can be the best in the world, right? So we can't turn everything into the Olympics. So we just say that we need to keep sight of that and just be accepting of the fact that 99% of everything is crap. I wouldn't go so far as to make
They're all beautifully a good thing for a project to be a standard definition TV. That's a nuisance these days. A lot of the older ones are I do have a website that has all the details on how to make one of those. If you,
I'm not sure I'm that ambitious.
I've got simple.
Shane, you can get like the miniature plates.
These are yours? My sister would really dig these.
Really?
Yeah, she.